Hello, everyone. Let me know if the sound is okay. Hopefully it will. Hopefully it will work out okay. So welcome to the stream. Welcome all of you Ranks people, and welcome to all of you returning zetamath people. But if you're new, welcome especially to you. Always great to see. Always great to see new folks around. One thing I wanted to mention is I've been putting out these videos of sort of sudoku tutorials, I've called them for lack of a better word. This week I did Snyder notation, which is how you sort of write down, although I'm told it's maybe not called Snyder notation, or maybe it's now called Snyder notation or whatever. Basically just the notation that Ranks and I and Simon and others use when they're solving puzzles, and that you can use when solving puzzles too. Now, I actually know that for the vast majority of people who regularly watch the stream, you already know this, so the content of that video is probably not super exciting for you. But many of you probably have friends who you're getting into Sudoku or who are just getting into Sudoku. And so if you do have friends who are getting into Sudoku or who are interested in getting into Sudoku, please let them know about the tutorial videos, and you can link them to the one from this week as the first one. So I recommend those, and we'll keep doing them. But they're just posted on the YouTube channel, so they're snipped out of the streams, and we do those on Wednesdays. So I don't know yet what Wednesday's tutorial is going to be about. I've been getting a lot of people giving me tutorial killer puzzles, so I'm probably going to have to do killer. That might be my plan for Wednesday. We shall see. The stream is brought to you by... can a mod take care of that? The stream is brought to you by all of our sponsors on Patreon and on YouTube. And in particular, every stream... can't talk today. Every stream I do the most voted on puzzle by all of my supporters. So this time, this is that puzzle. Okay, this is going to be a doozy. I will warn you in advance. But hey, whatever they vote for, I do it. So we'll see. I've been warned that this puzzle took Novario a while, but let's go over the rules. I did pre-read the rules just because I assumed that this was going to be a nightmare to do. But this is a Math Pesto puzzle, and Math Pesto puzzles are always amazing, and I greatly enjoy them. And I think Math Pesto might have the honor of being the most popular setter with the audience of supporters who vote, because I feel like more often than not, the most voted on puzzle is a Math Pesto puzzle, which, to be clear, I'm more than happy with. Alrighty, so this is a deconstruction puzzle. This is the Suguru style deconstruction puzzle. So what that means is we've got a 15 by 15 grid here, which is enormous, but a lot of the cells in this grid are not going to have any numbers in them. So a lot of these cells, we're just going to put a black thing in and just say there's no number going on in here at all. Well, that's good. Oh, and we have a super chat from David Ratner, who donates $18 and says, well, for 2 Math Pesto puzzles today. That's awesome. Yes, congratulations on your double feature Math Pesto. I am excited. Have I done the puzzle of yours that Ranks did earlier? Which puzzle did Ranks do? I don't actually know. I was only there for the gap at the end. So, as I said, most of the cells here will have no numbers in them. Some of the cells here, and this is the S cell part, some cells will actually have 2 numbers in them. And so we'll have what are called S cells, which will be cells here that feature 2 digits. So, for example, this cell could have nothing, or it could have both 3 and 4. Who knows? Okay. So we will see that. Yeah. So we'll do that again. So Kurabon makes a good point that I'm going to do this up here. Just to allow people to talk about what's going on. 3, 4, 5, 6, 7, 8, 9, 10, 1. Oops. not 7. 1, 2, 3, 4, 5. Okay. These are just so that when people refer to row 14, column 11, I can actually find row 14, column 11, because famously I am terrible at this. All right. So we've got some clues. And so the clues are circles and squares. And some of the circles and squares have numbers in them. Some of the circles and squares do not have numbers in them. When they have a number in them, what they indicate is they indicate the difference between the value of the two cells. So for example, whatever is here and whatever is here, they have a difference of 4. Okay. In particular, every clued cell is part of a region. So I know I am definitely putting a number in, for example, all of these cells. Those cells all have a number in them, which I'll indicate by giving it a non-black color. So we will keep track of this as such. Okay. Yes, I feel like people are capable of knowing that this 1 actually represents an 11. They only have to decide, like for this 3, this is the closest case. They have to decide, is this a 3 or a 13? And I think by eyeballing it, they can probably decide if this is a 3 or a 13, possibly. All right, so every cell that touches a clue definitely has a digit. Okay. But then the digits are all broken down into regions, which have at most 8 cells in total. And a region with n cells contains the digits from 0 up to n plus 1. So if this was a region, it would contain the digits from 0 to 9. And as the rules note, that means every region contains not 1, but 2 S cells, because I need to fit, for example, in an 8-cell region, I need to fit 10 digits, which means I need to put 2 digits in 2 cells out of the region. So every region is going to have 2 S cells. Okay. Now, the regions do not touch each other orthogonally. So actually, I'm doing this because I've done a few of these before. I want to note 8 is the most cells a region can have in it in this puzzle. So this is a region of size 8. I know that because of the following rules, just to make sure we go over this. Every clued cell has a digit in it. So all of these at least have digits. But also regions can't touch each other orthogonally. So I can't put a region boundary here. That's not allowed. If I put a region boundary here, I've broken the rules, because that's 2 regions that touch each other orthogonally. But I can only use the digits from 0 through 9. And so by this rule here, that I am mousing over, I don't know if you can see that, if I tried to put a 9th cell into this region, then what would happen is that I would now need to put a 10 in one of the cells, and that's certainly not allowed. So I actually get that this is a region before I finished reading the rules. And I also get that all of these cells that I'm now highlighting in black, none of those contain a digit at all. Okay, and we'll do more of that sort of thing in a moment, but I just wanted to go over that. Okay, so the numbers in circles and squares give the difference between the value of the 2 cells. So these 2 cells have the same value. Now, the value of a cell, if the cell is a regular digit, that is, if it's just a 7, the value is 7. But the way I could possibly make this work is that the value of a Schrödinger cell is the sum of its digits. So this 0 here is telling me that the sum of these 2 is the same. So they could both be S cells, or there could be. If there was one more cell in the region, I would need to have put a 10 in it, and I'm not allowed to put a 10. Thank you to Matt Pesto for not allowing me to put a 10 in. If I read the n plus 1 correctly, an 8-cell region needs to contain a 9. So also, while we're at it, we still have plenty more rules. So S cells in this puzzle do not touch each other orthogonally or diagonally. So one of these you can deduce, if you're sort of trying to deduce stuff already, one of these is an S cell, but they can't both be S cells because they aren't allowed to touch each other orthogonally or diagonally. And so we can pencil mark things like, I know that that's not an S cell and that's not an S cell, for example. That's probably how we're going to have to mark these things. Probably not using black, though. I'm probably going to use gray for that. Okay, I think I'm going to use gray for marking cells that can and can't be S cells. So a circle will be an S cell. Except for one circle is going to be a bet cell if MathPesto wants to tell us a bet cell. While I go over the rest of the rules. So you'll notice there are some pairs of cells like this that have a square between them, but no number. But what the square means is that the difference between these two cells is even, and of course these two cells both have to be glued. Hey Dale, welcome. And then the circle means odd, and the way you remember that is that the word odd starts with a circle, because it starts with an O, and an O is circular. So that is the way that works. Row 10, column 6. So I'm going to make the bet cell, I guess, red, row 10, column 6. So feel free to bet on what the bet cell will work out to be. The bet cell could be empty, it could be 1 digit, or it could be 2 digits. So bet whatever you like. Yeah, so JLib has the other thing, which is that a square has an even number of sides, and so you can think squares for even, because they have an even number of sides. I have an earbud in my my ear for no particular reason. Yeah, I guess the question is, can you bet empty, or is empty the house wins? I guess we'll have to see. Someone is betting empty, so I guess people can bet empty, it turns out. All right, I think I have nominally said... I don't think I actually said out loud. Digits can't repeat within rows, and there can't be more than 2 S cells per row or column. Sorry, digits can't repeat in a row or column, and there can't be more than 2 S cells in a row or column. Okay, so let's try and see if there's any other things we can highlight. So this is going to be a region. And while I'm noticing this, I'm going to point out, I think these two cells both have to be S cells. Because if these are not S cells, say this was the S cell, neither of these could be an S cell, and they would both contain the sum because of the difference of 0. So we at least have a little bit of generosity. That's an S cell, these aren't S cells, and none of these are S cells. I don't know if at some point I'm going to get rid of the X's for is not an S cell, but we can do that. I guess I don't really want to have an X in cells that don't contain a digit. I'm going to reserve Xing for cells that I know contain a digit, but contain exactly 1 digit. Now, exactly the same pattern suspiciously happens here. And for exactly the same reason, these two have to be S cells, and this can't be an S cell, and these can't be an S cell. Oh, but red has to actually continue down here, actually. So we've got that. Yeah, I don't know exactly how pencil marky I'm going to be. These have to be black, because I can't join these two for multiple reasons, but the easiest reason is this already has 2 S cells, so it cannot join a region that also has an S cell. So we get some black stuff there. Let's see. Okay, so where else do we have large confluences of cells? What about down here? Yeah, that's already 1, 2, 3, 4, 5, 6, 7. Yeah, we're going to make that green. Note, this definitely... So here's the kind of logic that shows up here. So here's another thing. We'll make that purple. These definitely can't be the same region, because that region would immediately have, like, 18 cells in it. So those can't join. Let's see, this is already at 7 cells. So, and a region in this puzzle has at most 8 cells. So, red can't take this cell, because it would then immediately grab all of those, and that would not be okay. This thing here, this little stub here, it looks innocuous, but actually it can't join purple, because if it joins purple, that would make purple at least 10 cells, and purple, well, that's just ridiculous. Purple can't be 10 cells. All right, I am going to go ahead and X these cells out. Those are not S cells, because I have 2 S cells in column 14. Let's not forget. So that means orange has to grow, because orange needs 2 S cells, and by what I'm going to call star battle rules, I can't put 2 S cells there. So orange needs another S cell, so orange is going to have to grow at least to there. And as soon as orange grows there, orange actually grows and takes all of these. And now orange is 8 digits, so now we can box orange in. Okay, purple is interesting. I guess purple can sort of escape down like that at least. So purple still has a little bit of liberty to give, not a lot. Let's see, where else is a cluster that I can highlight? Oops, what about that? 6, 7, 8. No, that's 6. Okay, this is good. I can highlight this one. I'm going to make this another blue because it's far enough away. This can't join this one. I'll make that another red because it's far enough away. These can't join because that would be a ridiculous number of digits. Yeah, there are at most 8 colored cells in a column. So some people in chat have pointed out I already have 8 colored cells in this column, right? 1, 2, 3, 4, 5, 6, 7, 8. Actually, is that true? I don't know if that's true. I don't think I know that there's 2 S cells in every column. I think I could have 9 colored cells in a column. I think I could even have 10 colored cells in a column. So I don't think I know that, because I don't think there's a rule that tells me that. And I feel good about that because Math Pesto immediately jumped in to say, no, that's not how it works. So good thing. Yeah, we got that one just barely by the skin of our teeth. I was going to believe it. Let's make this another green. Let's see. This green is huge. It certainly can't join whatever this is. This is going to be another orange. Green and orange certainly can't join. Green is already at 7 cells, so green can't take this, because then it would join this razzmatazz gang. Green can't take either of these. It cannot join the 15, because that would be too many. Let's see. This is already at 5. Yeah, so if it took one of those and then took the 8, that would be okay. This is 5, 6, 7, 8. That would be okay as well. Let's see. This has to be black, because if this is not black, then green actually absorbs these two. That's not okay. Let's see. I think I want to, and I will see, I may horribly regret this immediately. I think I want to put in light gray every cell that I know definitely contains a digit, but that I don't know what region it's in. So I'm going to make all of those light gray, which is not the most standoutish thing, but it's also not the biggest property to claim of something. But these cells all contain digits. I just don't know what digit. Okay. Every colored region I know does not join another colored region. That is the way I have labeled my colored regions. Okay. So, these are not S cells, because red already has 2 S cells. Orange, I guess, doesn't necessarily need to have an S cell over here, but if orange doesn't have an S cell over here, then the S cells in orange are in those 2 cells exactly, because note orange is done. Does there have to be an S cell here? Maybe. Oh, yeah, because I can only fit one S cell in purple in this column. Yeah, purple needs 2 S cells. That is certainly true. I think one of these has to be an S cell, because no, maybe not. Maybe I could fit one there and one there, maybe. 1, 2, 3, 4, 5, 6, 7, 8. Aha! Yes, good spot by Eric. So it's not true that there's any cap on numbers of cells or whatever, but I have already put the digits 0 through 9 into column 14, so there is nothing else I could put here. So this is not part of anything. Okay. And so now, because that's not part of anything, it's definitely true that one of these is an S cell, and it's definitely true that one of these is an S cell for purple, because purple needs 2, and there's no way that purple avoids getting 1 in column 15. So these in particular are not S cells, because purple needs to have an S cell in column 15. And then that, together with this blue S cell, that's all of them. And so now I know where the S cells are in orange. And this is, again, by, well, maybe not quite. I know this is definitely an S cell. I'll go that far. This is definitely an S cell, because if it's not, I have to fit 2 S cells in here, and I can't. That does finish all the S cells for column 13. Means that's not an S cell. This now is an S cell because this is a 0, and remember that zeros can't have things. Or there can't be a 0 without an S cell. Purple needs to have an S cell up here because purple gets only 1 S cell in column 15. So this is going to have to be an S cell. That's the last S cell for column 12. So that's not an S cell. That's not an S cell. Cool. Okay, so now this isn't an S cell and this is an S cell because S cells can't touch diagonally. So we're in doing okay. We're having an acceptable start here, I feel like. One of these two is an S cell. Do I know which one yet? I don't think that I do yet. I know, of course, one of these two zeros is an S cell, but that's far enough away from me at the moment. Okay, so here's a thing I know. I'm just going to keep making up notations. There's an S cell in these two. There's an S cell in these two. And so that's all of the S cells for row 4. And so these 2 cells cannot be S cells. So that is at least something. I know there's an S cell in those 2. There's an S cell in these 2. There's an S cell in these 2. Let's see. And a Schrödinger cell Seguru deconstruction, no less, Nicholas. Just so many delightful things. Okay, so for example, a 15, I definitely can't do a 15 difference. I can't do a 14 difference without an S cell being involved. So there's a few more gimme S cells. An 11 difference I cannot do without an S cell being involved. 0 and 9 are 9 apart. Okay. So, what else do I want to do? Okay, yeah, these have a difference of 1. That's not exciting. These have a difference of 2. Let's see, I don't think I know anything about this. I don't think I know anything about that. Let's see. Row 10, column 9. Can't be an S cell. Ah, yes, there's 2 S cells in this row already. Gorgeous. Well spotted, Jaleb. I had not paid attention to that, but right, there are 2 S cells in this row already. So, in fact, that's the S cell out of this pair. Hey, Math Coding. Love the screen name. Hope you're enjoying being tipsy. Well, granted, I'm only like 20 minutes into it, but I'm really digging this puzzle so far. 1, 2, 3, 4, 5, 6, 7, nowhere near being done for the row. 1, 2, 3, 4, 5, 6, nowhere near. Okay. Yep, one of those is. Oh no, are we running out already of deducible things? Oh, I know this isn't, because it touches anything that touches both places an S cell could be is certainly not an S cell. So that is it's a very weak deduction, but that is not an S cell. Oh, these two can't join, so those are both black. That's at least something. Let's see. Is it possible that blue is only 6 cells in size? I think it's possible. Black in column 13 and column 15. 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 cells, 2 of which are S cells. That's 10 digits. So that is black. 1, 2, 3, 4, 5, 6, 7. Aha, right. And then I know there's a purple S cell. And so as soon as I know there's a purple S cell, that's all the digits in column 15. So this has to be the purple S cell. And then these all have to be black. Oops. These all have to be black. Because once I know that the last purple cell is an S cell, that's all of the cells that exist in column 15. That's cool. Okay, so that's all the S cells for row 13. So I can happily X... Oops. Sorry. I can happily... Oops. Ah! No! Disaster! I can happily X those two, because that's all the S cells for row 13. So now the only way blue doesn't extend is if these two cells are both S cells, which is interesting in and of itself. Green is at 1, 2, 3, 4, 5, 6, 7. Green is at 7 cells. So green is somewhat limited. I wanted to look at these and see if there's anything mathematically interesting going on. So this is the digit 0 through 6. That's almost interesting, I feel like, that this is the digits 0 through 6, but not quite. Yeah, I don't think I can quite deduce anything from that yet. Okay, Garion is looking at this and noting that it is difficult to place a 9 anywhere else in the column. So I certainly can't put a 9 in this S cell, because if this were a 9, it would be 9 plus something and would need to equal that. That's not going to work. None of these are 0. 9 on here would require an 8. And if I put a 9 and an 8 here, then now it's impossible to get it. Oh, could these be 0, 7? Oh, red's not allowed to have a 9. Thank you, Garion. I completely missed that red is 7 cells. So yeah, red doesn't get a 9. Okay, so gorgeous. Red doesn't get a 9, but there has to be a 9 in column 15, because again, we have all 10 digits appearing in column 15 by counting. Great spot. I totally was going to miss that this wasn't allowed to have a 9 because it wasn't big enough. Okay. So then the only question is, could the 9 be here in purple? And the answer is no, because this is way not close enough to have a 9. It's not big enough. So yeah, so this is a 2-9 pair to go there. I'm going... Once I have pencil marks, I think I want to get rid of the X's. If I know it's not an S cell. I think we're going to try and keep track of that, although it might be a disaster. Okay. So then Eric's question is, where is the 9 in column 14? Because column 14 also has all of the digits. Can't be in purple. Orange already has a 9, can't be in red, so the only place for the 9 is here. And we, in fact, we have our first digit, so we get to have our 9 dance. Woohoo! Nine dance. 9 dance. Thank you, Zach. Thank you. Much appreciated. He just wanted a little more screen time. Thank you, Zach. All right, so this is a 9. Yeah, figuring out where I can remove these things is tricky, but we'll do it. But I'm not eager to remove X's from cells unless I have a very good reason to. So it is true to note that blue now has to be 8 cells. So blue is currently sitting at 5 cells. If blue wants to get to 8 cells, it can't do that without taking one of these 2 cells. Blue could only get to 6 cells. So blue has to take one of these 2 cells. But as soon as it takes one of these 2 cells, blue takes these 2 cells. And so blue currently consists of, proven, these 7 cells, but it only gets 1 more. So this cell is blue, these light gray cells are blue, everything touching this is black. These are not S cells, for sure. Let's see. Okay, so we've got that 9. What about this column? Does this column have all the digits? I think it does. 1, 2, 3, 4, 5, 6, 7, 8. It does. This column has all of the digits. I can't put a 9 in orange or purple. I could put the 9 in yellow, can't I? Yeah. So the 9 in this column either goes in yellow or in green, but I don't know which one. Let's see. Okay, so do I know anything about this 9 difference? So I have to make a 9 difference, but the 9 difference involves an S cell, so maybe I don't know anything about the 9 difference as of yet. Let's see. I still can't... let's see, this is 5. This could still join up with that. That's still okay. Kurbon says green must extend to row 15, column 12. Column 12 only has 9 digits. That's fine. Columns don't need 10 digits. There is no obligation to put all of the digits in every column. In fact, I think we could probably prove that there will be columns that don't have every digit. What we can say is if this is in a region, then it's not an S cell. The 8 difference in blue. Ah, right. These are 8 different, and they don't involve a 9, but they're honest. So these are, in fact, a 0, 8. Got it? Okay. So these are 0, 8 just by sudoku. Never mind the corner marks. The corner marks have nothing to do with anything. So now my sums to 9 don't involve a 1, 8, but I guess there's still several ways to sum to 9. Let's see. Eric is looking at row 1 and row 2, column 10, and column 8. I don't know. So the reason why, Martin, has to do with a combination of a few different rules. So Martin asked why this has to be 2, 9. And the reason why was I need to put a 9 somewhere in this column, because if I count, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. So this is all of the digits 0 through 9. So the 9 has to show up somewhere. But by the rules, the 9 can't show up in either of these two regions, because a region's size dictates what digits are in it, and only a region of size 8 is allowed to contain a 9. And so the 9 was ruled into one of these places. Those are the only places. But if I put a 9 here, it breaks immediately when I try to make this work. So that's how I knew the 9 had to be here, and once the 9 had to be here, it had to be 2, 9 exactly. Row 10 already has 10 digits. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It does. Beautiful, beautiful, beautiful. Okay. So the bet cell has been resolved. The bet cell was empty. So congratulations to whoever it was that bet the bet cell was empty. I think it was Martin, wasn't it? Okay, so sorry, bet cell. Tricky. Yeah. So that was a very good observation by Jaleb. Congratulations, 57. Okay. This 14, I again know, definitely involves lots of shenaniganery. The S cell, actually, I guess I could pencil mark things that could be in this S cell, but I don't know that I really want to go down that road yet. That sounds like it's going to be a road that leads to places that I don't know that I want to go. Let's see. I don't really want to pencil mark all the possible ways to make a sum of 9, unfortunately. That just seems too much at the moment, Nicholas. I know I can't do 1, 8, but I could still do 3, 6, or 4, 5, or 2, 7 even. So there's still lots of ways to make this work. Oh, right, because it's separate. It's not that these two sum to 9. This one sums to 9. So yeah, so there's only 2 pairs. It's only 3, 6, or 4, 5. That's still, I'm not going to pencil mark that. Yeah, this can't be 2, 7, because there's already a 2 in the column. So this is 3, 6, or 4, 5. And this is not a Kropke dot. I keep thinking in my head this is a Kropke dot. It is not. This is an actual Kropke dot, for whatever it's worth. This is not an S cell. Sorry, this is not an S cell, because it sees both places the S cell could be. Row 4 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits in it. So these are all black. Great spot from Eric. Very well spotted there. So we have that. The squares and circles don't mean anything about consecutive. This just means the difference between these is odd. I could probably count odds and evens in this column. This sounds painful, but it seems like a good thing to do. So this is 1 odd and 1 even. Together with that, that's 2 odds and 2 evens in the column. This is also an odd and an even. So that's 3 odds and 3 evens in the column. So I have 2 odds and 2 evens to put here, which is exactly enough to tell me absolutely nothing. Actually, I guess it does tell me one thing. This is either 2 odds or 2 evens. So this cell is either 2 odds or 2 evens. And so this cell's sum is always even. So this digit is always even. So this is a 2, 4, 6, or 8. I think I'm comfortable dxing this, but this is always a 2, 4, 6, or 8 because this always has an even sum. That was my reward for doing that whole exercise. So let's see. Let's do this column maybe. So 1 odd and 1 even, 2 odds and 2 evens. 2 odds and 2 evens. Yeah, this can't be lots of things. Oh, but it can be 0. No, it can't be 0. Okay, so sorry. Let's go back and let's pencil mark this better. So it could be 0, except that it can't, because if this was 0, I would need this to sum to 2, and I can't make this sum to 2. That's not possible. This can't be 8, because this region is not big enough to contain an 8. So this is 2, 4, or 6. I don't think I can do better than that, unfortunately. But I'm trying to count in this column if I know anything. So what's the minimum this digit can be? Maybe I don't really feel like I want to calculate that. So 1 odd and 1 even, 2 odds and 2 evens. If this digit is odd, then it means each of these contains 1 odd and 1 even. So let's imagine the world where this cell is odd. So we're now at 3 odds and 2 evens. And now we're at 5 odds and 4 evens. And so this would be even, but that does not immediately tell me anything. I do not think. Right, okay, there is a 2, right. So red has a 2 up here, is Nicholas's point, because the 2 here rules 2 out of all of these cells. So one of these is a 2. It's not that one. One of these contains a 2, so there's no 2 here. So this is only a 4 or a 6. That is a good spot to Nicholas. Let's see. I do need to put a 1 in blue. I can't put it up here, so the 1 is down here. If it were on the dot, it would have to be 1 and 2. But I don't immediately see what's wrong with that. Let's see. What about blue? Blue has... Okay, so I know this digit's odd. Blue has 2 evens here. 2 more evens here, that's 4 evens. 1 more even here, that's 5 evens. And remember, in this puzzle, there are 5 evens. So I actually know this cell is odd. I think this puzzle is going to be all about pencil marking when I know what parity a cell is. Okay, I think I have internalized that I know that these are... no, I'm not going to do that yet. Let's see, I'm going to try and start internalizing that I know that these aren't S cells, but we can do that. Okay, so what is the even cell in this dot? I guess it's 2, 4, or 6. I feel like this is going to become completely unreadable if I pencil mark the ones here, given that I have the 1 corner marks up here. I might do that. Okay, so let's look at this difference of 8 per Eric, I think, wants to look at this. So if there's no S cell here, how does this work? So it's not 0, 8, because there's a 0, 8 there. It's not 1, 9, because there's a 1 over here. And so 0, 8, and 1, 9 are the only ways to make a difference of 8 without an S cell. And so I think Eric's point is I can pencil mark an S cell into this thing. So we have that. Oh, Math Pesto suggests looking at 8 in column 15. So this can't be an 8 because this region's not big enough. This can't be an 8 because it would need a 1. So there's an 8 in one of these cells, is Math Pesto's point. And so once I know that there's an 8 in one of those cells, then I need to think about where the 8 goes in column 14. So now it's not in any of those places. It's not in purple. And so the 8 in column 14 has to go here. And so this is a 7-8 pair. That is Math Pesto's point. That is a very cool observation. Okay, so now this cell is looking super juicy. Because this cell now is at most 6. But it's a sum of... Back up? No? Uh-oh. Why does it have to be a 7-8 pair? Oh, because it's not a Kropke dot. Dang it, Pesto. Using these circles like this is cruel and unusual. Yeah, this is just an odd and even. Sorry. Okay. So this could still be a 7. Never mind. Yeah, it's an 8 and an odd. Okay. So the sum of these 4 digits is at least 10, because I cannot notably put a 0 in either of these spots. Oh, that's a good point. Where does the 0 go in this column? I think I can place the 0. So the 0 can't go in any of these cells. The 0 can't go here because there's an 8, and so I think the 0 has to go here. I don't think there's any other choice for where the 0 goes in column 14. That's a good thing to be thinking about, is where the 0 goes. So this digit's even. So this is 2, 4, 6, or 8. Sorry, 2, 4, 6, or 8. No, not 8. There's no 8 in this region. Row 2 has all 8 digits, I am being told. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I only count 9 digits in row 2. Am I missing something? Okay, so I want to chase this 0, because this region contains the numbers 0. So the even numbers this region contains are 0, 2, 4, 6. There's an even number in this cell, because this cell has to be an even and an odd, because this is even. So this needs to sum to an odd number. So this is an even and an odd, which means that this cell over here is odd. So all the digits in this cell are from 1, 3, 5. The other even digit is over here. And so if there's an even digit included here... Oh, wait, no, sorry. I was about to assume that this was a Kropke dot again. It's still not a Kropke dot. It just means... Literally all this means is exactly what I just said, that this cell is an even and an odd. Let's see. But this is 2 odds. So let's see. So this column has an odd here. That's 2 odds. That's 4 odds. Okay, so that's 4 odds in this column. So these are both even. These are from 0, 4, 6, 8. Oh, except not 8, because we agreed... No, there is an 8, right? There is an 8 in red in this column, sorry. There is an 8, there's not an 8. So these are from 0, 4, 6, 8. Because these both have to be even. They can't both be odd anymore. The last odd digit in the column is on this thing. Why can't this be a 1, 5 with a 4? Can there be two? Do there have to be two evens in red? Aren't there only two evens in red if this is... I don't think this has to have two evens in red. That's only if this is odd. If this is even, these could all be odd, I think. Is that possible? Can I rule that out? Am I chasing this rabbit hole too deep? I guess there's 3 evens. Oh, right. Okay, so there's 3 evens in the column here is the point. So I can just count. I see. Okay. Sorry. I thought you were arguing from this, but you're arguing from this. There's 3 evens in here. I can just count them. So there are 2 evens over here is the point. There's always 2 evens over here. And so if there's 2 evens over here exactly, that means this digit can't be even. So this digit's odd. Because if this digit was even, there would be an odd number of evens in here, and there's an even number of evens. Okay, now this can't be 9. It's certainly not 1, because the 0 in the column is gone. It's not 3, because the 0 in the column is gone. So this is 5 or 7. Those are the only options. So yeah, so if this was 5, this would be 1, 2, 3, 4. If this was 7, we'd have more options. Oh, I know there's a 2 on it. Let's not forget that. There is a 2 here in one of these 2 cells. I don't know which. Don't think it matters, though. Yeah, I don't think any of it matters at all, as things currently sit. So I think we should poke a little bit at seeing if we can stretch any of this parity logic into, say, column 13. Because we haven't yet looked at column 13. Yeah, there's always a 2 and a 5 in here. I'm not corner marking that in an S-cell puzzle. But it's true. There's always a 2 and a 5 in here. Should I look at this string? This string is interesting. So is this odd or even? So we've got 2 odds and 2 evens gone. Already in orange. So over here there are 3 odds and 3 evens. Yeah, maybe that doesn't help me. I don't think that helps me, unfortunately. I know there's 1 even here. I know there's an even there. That's 2 evens just looking at this column. If these were even, that would be 4 evens, which is not even quite enough. Oh, you just want me to center mark this? I can center mark this, I suppose. So is 8 with a 1, a 3, and not a 5, or a 7, not a 9. So 3, 7, or 1 are the options. Actually, is 1 possible? I think 1 might break this cell. If this is a 1, then now this has to be 7, of course. And now as a result... Oh, no. Sadly, it works. It works excellently. If this is a 1, then this is a 7, and it's 3, 4, and 2, 5. And so then, of course, this is a 6. It just works itself out. Sad but true. Yeah, I know one of these two is an S cell. Let's see, these are a difference of 0. I know this contains a big digit. Can I prove that the 0 in orange is here? Probably not quite. Close, though. But not quite, I don't think. There's a difference of 6. So this is J-Porty's point between 2 orange cells on the 3, 9. Ah, right. Oh, wait, does this have to be a difference of 6? Is that true? Could it be a... Well, it can't be a difference of 12, I suppose. So yeah, so if I think about how these two digits are related, they have to be 6 apart, because otherwise they're 12 apart, and they're single digits, so they can't be 12 apart. So these are either 0, 6 or 1, 7. So interesting though, if okay, so yeah, so we're saying like 6 here, go up 3 to a sum of 9, and then go down here, whatever. Yes, this is a very simple, straightforward puzzle that my supporters voted for. In fairness, it's very cool, and I don't think any of it has been especially difficult so far, although I fear that is going to change. But so far, it has been fairly benign. So I do believe, Jay, I think I believe that the sum of this S cell is always 9 or 10. If we really want to use that, I probably want to double check it, but 4, 6. I was just thinking through what are the ways that I could make that. The 9 clue and row 14. Okay, Nicholas wants me to look at the 9 clue and row 14. Why would the 9 clue require an S cell? Do I know that it's not 0, 9? I don't think I know that it's not 0, 9. Right. So the way this works is that this is tiny to this being big. So this sums to 9 or 10. Going down to then this summing to 6 or 7 is what's being pointed out. So are you saying if this is 6, it doesn't work? Stupid 0. Yeah, the 0 is always the real worrying part in S cells. Let's see. Why can't row 10, column 12 be a 1? So if this is a 1, this cell sums to 4, and now I need this cell to sum to either -5 or 13. And because this is known to not be an S cell, it cannot sum to 13. Hey, Grockles, welcome! We're doing our nice warm-up puzzle today. Yeah, that was J40 spotted the interaction between this 3 and the 9. I had not spotted that either, Dale, but I think it's pretty cool the way it works out. Let's see. Are there any other digits that are interesting to chase through these columns? Because column 13 and 14 have been very productive so far. But I don't know that there's anything else we're going to get out of them. Yeah, 5 and 4 definitely live in these S cells because they're not pencil marked anywhere else, and we need to put them into the hoodinkity. Purple doesn't have a 7. Purple is only 5 cells, so purple's biggest digit is a 6. These is a 2, I know. Okay. Fancy dad prowess. I bet you very much excel at the dad jokes department of being a dad. Let's see. Okay, so if these are 0, 6, the question is, how does this 9 sum work? And I think the answer is it's 4, 5, right? Let's see, row 10. Yeah, these 2 digits, they do appear in orange. And they are, these digits are authentically consecutive. So this is SPQ's point. We could think about where the 2 consecutive digits are out of these 3 cells. So 2 of these 3 cells are consecutive. And so that could be 0, 1. It could be 2, 3, or it could be 8, 9. I think those are the options for that. Oh, or 1, 2. 1, 2 is also a possibility. I know that this digit is very small. What is the largest this digit could possibly be? The largest this digit could possibly be, I think, is a 3. So I should probably write in that this is 0, 1, 2, or 3. Just for my sanity. Because I need to add up here to a number that is at least 14. don't think that does an enormous amount to help, though, sadly. So 7 in row 10 is orange. Does row 10 get a 7? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, the 7... right, so the 7 in row 10, I cannot put a 7 here, because if I put a 7 here, I have to put a 7 there, and now I need to put an 8 or a 6 in one of these two, and I can't. That is a great spot to SPQ. So there is a 7 in this gajillion cells, so this cell's never a 7. We can at least eliminate that. Hey, Isabella, welcome. That's a good point. These 3 cells are exactly these 3 cells. Ambrose points out. That is true. Let's see, what is this down here? This is a 0, right? Yeah, this is a 0. Let's see, these are 6 different... I was looking at if it was possible if these were even, but I think it is. 10. Yeah, these are a 1 difference. That's the rules. That's what the 1 in a circle means. I kind of fear this is going to join red. Let's see, should I look at this 15 difference? Is there anything interesting about the 15 difference? I don't think so, honestly. I mean, it's going to have to involve some big digits, but who cares? Yeah, I feel like I'm supposed to be finding the right place to count odds and evens, but I have not found the right place to count odds and evens. Maybe this row? I don't think so. I think it could be 8, 9, Nicholas. Big digits means it's a big region, that's true. Certainly the 15 difference is in a big region. But I mean, it could still join over here and be fine. That would be 8 cells. There is no rule that all of 0 through 9 must appear in every row and column. Correct, Ringsk. In fact, we know it's not true because there are regions of size less than 9. And so there are strictly fewer 9s in the puzzle than 15. This row is really close to having all of its friends. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9. It has 9 digits. So if any of these things are part of a region, they're not in an S cell. And we have a couple other places where that's true, like this cell, I think it's also true. Yeah, I am somewhat mystified at the moment. In row 2, 1 is always in blue, yep. We have an imaginary 1 corner mark. I can turn it into a real 1 corner mark. Enough time is passing, it's probably not a terrible idea to mark that we know that the 1 in blue is down here, because the 1 is not up there. Let's see, if the 1 were on this, that would make for 3 odd digits right there. Oh, that's too many odd digits. This can't be the 1. No. Darn it, I counted wrong. Don't listen to me. Don't listen to me. I can't count. It would make for 1, 2, 3, 4, 5. It would make for 5 odd digits if that's the 1. Doesn't matter. Okay. So Jay says there's 2 options for here, which are 3, 6, or 4, 5. And so the key reason why Jay is interested in that is it means that this can't be 3, 5. Because if this were 3, 5, it would break this cell. There would be no way of making a sum of 9. So this cell definitely contains a 1. So this cell does not contain a 1. And so that means that the 1 in this column is in one of these 2 cells. Sorry, that means the 1 in red is in one of these 2 cells. It means there's no 1 in orange over here. Yeah, so the 1 and the 2 are over here, if we want to mark that. So this is either 1, 2, 3, 4, the 5, or it is 1, 2, 6, 5, with that. My attempts to keep the pencil marking in this puzzle reasonable are slowly slipping away. Okay. Darn it. So this could be 1 and 3, making this a 6, or 1 and 5, making this a 4. Those are the options. Yeah, I can probably... oops, sorry. I'm going to leave this circles, but I can remove the X's here and try and keep track of this. 3 could be here with a 2, summing to 5. I don't think 3 is forced into red. So we either have a 3-4 pair or a 5-6 pair over here. I guess I should say we either have a 3-4-5 or we have a 5-6-7. Those are the 2 options for what the other things here are. Yeah, well, we're hoping to add some more color over here at some point, Grackles, but it's been proving surprisingly stubborn about that. Means that row 12, column 12. Let's see. Martin says the 1 here might mean that this cannot be 2, but I don't see why. One in orange is in one of these spots, I believe. Row 12, column 13, that cell. Why would it have any impact on this? I might be missing something. Red in column 14 needs a 4 or a 6. I agree with that. Because the other 4, 6 in the column just has to go in red. is the point. I suppose I could mark one of these. No, I just know that one of these is a 0. I don't know where the 0 goes. 4, 5, or 4, 7 for row 10, column 11. This can't be 4, 7. Do you mean 4, 5 or 4, 6? To Eric. So 4, 7 would sum to 11, which is too many. But I think people's point is there's always a 4 in here, because this needs to sum to 9 or 10. But it can't be 1, 8 or 1, 9. So this can't involve a 1 or a 2 or a 3. And so we're summing to 9 or 10. If we're summing to 9, we're 4, 5. If we're summing to 10, therefore we're 4, 6. So this is always from 4, 5, 6, and there's always a 4 in it, is what chat is arriving at. I agree with that. There's always a 6 in row 10, column 11 or 12. Yeah, one of these two is always a 6. Do we just want to pencil mark the candidates into this cell? Maybe there's only 2 of them. Who knows? I don't think we know that it can't be a 0 or a 1. Can't be a 2 or a 3 or a 4. I think it could be a 5. It can't be a 6 because of the point Ranks just made. I think it can be a 7. And it can't be an 8 or a 9. So this is 2 of 0, 1, 5, 7, I believe. And in particular, it definitely concludes a 5 or a 7. Oh, it could be a 3. Sorry. This was a fool's errand. I don't know why. I forgot about 3 existing momentarily, it would seem. Yeah, I keep trying to count parity in columns, but we don't know enough digits, I don't think. Yeah, it has to contain the other 0 or 1. So these are a 0, 1 pair. Plus another digit. Row 12, column 12. Cannot be a 1. This is not a Kropke dot, Martin. That's the problem. This just means the difference between these two is odd. So I think learning about this didn't actually change anything. So the sum of these two is odd, meaning that this cell contains 1 odd digit and 1 even digit. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, we're still missing 1 possibly digit in this column. Yeah, Ranks was looking at these options, because these 2 cells, again, end up in these 3 places, and so there's only a finite number of options. But there's not a 2 here. What are we talking about? I think I'm missing something. Yeah, so 1, 2, 2, 3, or 8, 9 is what chat is telling me are the options for this. I believe that. That sounds good to me. 8, 9 does require a large region. It could easily join this region. If this were 8, 9, it could not, interestingly, join this region, which I also know is large. Hey, Naverio, how are you doing? Please remember to like the stream. Thank you, Naverio, for the reminder. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we only get 2 more cells in this row. Are your exams finally completely over Naverio? Let's see, okay. Where do 7s go in the last 2 columns is Math Pesto's next question. So either this is a 2, 7, or there's a 7 on this. But I mean, it doesn't matter at all, I don't think. Oh no, this can't be a 2, 7. Got it. Ah! Wait, this might actually be useful. This can't be a 2, 7. So the 7 is in red. Got it. Okay, so that does do something. That makes this a 5. Makes these a 1, 2, 3, 4. Thank God. Makes these a 1, 2, 3, 4. Makes this an 8. Makes this a 7. Means this is not a 7. These aren't 4, of course, anymore. This is now a 6. This is now not a 5. Because now this needs to sum to... this now needs to sum to 4 to be 2 different from 6. This isn't a 6. Why must the column have a 7? Because the column has 10 digits, is the answer. So if you count, this is 1, 2, 3, 4, 5, 6, 7, 8, plus 2 S cells is 10 digits. Why was row 10, column 14 a 7? Do I need to back up? Because this cell's an 8, the 3 is gone in the column, and so that's an 8, and now 7 is the only option for this cell, Garion. Yeah, it was just a naked single. This is 2 or 4. Let's see, what is left in here? We've got a 0 and a 1. We need a 2. We've got a 3. We need a 4 and a 5. This is from 2, 4, 5. That 7 makes that a 6. That a 0. This a 4, 5. This is not a 5 anymore. It's not a 0 anymore. This is a 1, 3. I was about to remove this 3 pencil mark, but this 3 pencil mark is not a real pencil mark. Okay, so now let's carefully examine if there are restricted options for this. So it can't be 0, 9, can't be 1, 8. I think it could be 2, 7. It can't be 3, 6. Could be 4, 5, I guess. Yes, okay, good point. We can continue chasing now. Remember, 2 of these 3 cells are those 2 cells. 2 of them have to be consecutive, so this one can't be a 2, or that would not be the case. So that's a 9 and a 2. This is an 8, 9 pair. Which, now, this 8, 9 can't go up. Because if this 8, 9 connected up here, why was row 13, column 15, not a 5? Because then I couldn't make this difference work. This was a 6, and this needed a sum that was 2 different from 6, because there's a 1, 2, 3, 4 quadruple up here, is the answer, Eric. These 8, 9 here mean this can't go up, because if this goes up, now the maximum digits I could put in the S cell up here are 7, 6. That's only 13, so that's black. So we now know that this goes down. Right. This thing now is huge, right? So it definitely grows. So it has to grow through there. And it's bigger than that, so it even has to grow through there, because again, it can't grow down. These two can't connect. So this now can get awarded a color. This can be another yellow. These, I know the color. They're red. They connect to this. This cell is not 1, 2, or 3, so it's a 0. These sum to 14 without using an 8, so it's not 6, 8. So the only other option is 5, 9, I think. So it's not 6, 8, and it's not 7, 7. So I think this has to be 5, 9 in order to be 14 different. One of these two is red, but I don't know which. Oh, I don't have my other S cell here yet. I know these aren't the S cells, but yeah, somewhere in here there is an S cell for red. Yellow is done. Yellow is done. So yellow gets black around it. Thank you, Eric. The rest of red gets black around it, because red is going to be done once it connects up here. This cell is never going to be part of a region, because it would have to be at least size 2, and can't be. So red is either this, or red is this. Those are the only options. Okay, that seems to have done a lot of damage. Let's hope it did anything valuable whatsoever. Yellow cannot take another cell. Yellow is 8. 8 is the only number, or 8 is the most cells that a region can have, Nicholas. Because every region has 2 S cells, so you can have at most 8 cells. Okay, these digits I can write down. They definitely include a 7, I guess, is the point. And so they are from 7, 0, 2, 3, 4, 5, 6, and 8. Okay, that was terrible. I don't know why I bothered writing that in. So there's definitely... Okay, so this cell's fixed. Because now there's definitely a 6 over here, and a 7, and an 8, and a 9. So this can only be 4, 5, is the point. So that's not a 5. So now this cell can't be 4, 5, 1, 8, can't be 3, 6. So I think this cell can now only be 2, 7, right? Not 0, 9, not 1, 8, not, could be 2, 7, not 3, 6 because of the 3 in the column, not 4, 5 because of this. Yes, this is now 2, 7. So that's not 7 either. What digits are left in this region? The digits that are left in this region, we've got a 1. Sorry, we need a 1. We've got a 2. Sorry, we've got a 0. We need a 1. We've got a 2. We need a 3. We've got a 4 and a 5. We need a 6. We've got a 7, an 8, and a 9. Okay, and this cell's not 1 or 3, so this cell's a 6, is the point. So this is not a 6, it is a 1 or a 3. 6 was the only value that could go here. That 2, 7 looks down and makes this a 4. Means that this is not a 4. This is a 2, 5. And it's done. It is a 2, 5. There is no further discussion about it necessary. Okay, so This cell can't... Oh, sorry, no, this is not the S cell. Never mind. I was excited, but this cell's not the S cell. So I don't think I know very much about it. Okay, so this is a 2, 5. I'm looking at 6s. Yeah, there's a 6 over there somewhere. Is this a 0? No, that's an 8. Well, what I can do is I can box in regions that are completely done. So that region is completely done. Just as a matter, this region is completely done. Just so that we know what we're looking at. Okay, let's... Yes, the color choices for the pen tool are the quality of life improvement that no one knew we didn't know we needed, but that turned out to actually be awesome. So this column needs a 0. It's got a 1, a 2, a 3, a 4. It needs a 5. It's got a 6 and a 7. It needs an 8 and a 9. Okay. The sum of the two digits here is not 0, so that's at least not 0. So this is 5, 8, or 9. Let's see, if this were 5, annoyingly, it would allow 1, 4 as an option. But hey, I feel good about this number of pencil marks. Hey, Franco, how are you? Let's see. Oh, interesting. Yellow needs a 6. The yellow 6 can only go on this dot. It's not the biggest deduction in the history of the world, but the yellow 6 goes over there somewhere. In fact, it might be the most minuscule deduction that has ever been accomplished in a sudoku. The yellow 2 also goes over there, actually. The yellow 2 goes over here. So there's only one more digit over here. And if the 2 and the 6 both go over here, this is definitely even. Oh, wait, no, sorry. The other thing that goes over here needs to be odd, because there needs to be an odd digit over here. So these things are 2, 6, and then an odd digit to be named later. Yeah, so... right, the 1, 3 is ruled out here. This 1, 3 goes in here somewhere. So these are from 1, 3 to 6. Good point. So 1 and 3 are ruled out of here completely. This 1 and 3 is ruled out of those. So that 1 and 3 goes in there. 5 is impossible. Row 6, column 13. So if this were 5, I would need this to be 1, 4. And that breaks... For why does this being 1, 4 break? There's always a 1 in the 0 difference yellow in column 1, in column 13. Okay, so so the claim is this cell always contains a 1. That would be exciting. Okay, so if this cell doesn't contain a 1, I know it doesn't contain a 0, and so so that's right out. So it doesn't contain a 2 either. So if this doesn't contain a 1, the smallest digit it could possibly have in it is a 3. But it can't have a 5 in it either. So the minimum this would sum to would be 3, 6. No, can't have a 6 either. So the minimum it can sum to would be 3, 7, and that's broken. Okay. Excellent, excellent. Well spotted. So there's definitely a 1 in this cell. So there's no 1 up here. These are 2, 3, 6. That 1 looks up here, makes a 3 and a 1. That was very well spotted. I see your link. I don't know if that means other people do, because I'm special today. So yeah, so these are 2, 3, 6. And in fact, these cells are a 2, 3, 6 triple. I'm going to just try and remember that this is a 2, 3, 6 triple. There is a 1 here. So this is either 1, 4 for 5, 1, 7 for 8, or 1, 8 for 9. And unfortunately, it seems to me like literally all of those are possible. Because Math Pesto is a bad person, and they made this an evil puzzle. Okay, what if there's no 1 here? Does that break? If there's no 1 on this, because this is one of my S cells where one thing equals the sum of the other 2. If there's no 1 here, there's no 2, 3 either, and no 5. So the minimum sum would be 4, 6, which is 10. That does not work. So there's definitely a 1 in the S cell here as well, for the same reason. So that is technically something. Technically not nothing, as they say. Okay, so 1 in green could, I suppose, go there. Otherwise, 1 in green goes in there, although that doesn't seem to tell me anything. I've got a 1 there. I've got a 1 there. I've got a 1 there. So the 1 in this green is getting pushed over bit by bit. The 1 in red, actually, is getting pretty bullied. So the 1 in red is in one of these cells, for whatever that's worth. The 9 difference in yellow. Oh, the 9 difference in yellow. Right, that is a good thing to point out. I had completely neglected the fact that this 9 difference in yellow exists. So this has to be the S cell now, because there's no way for this to be 9 different otherwise. I can get rid of the line. And now once that's the S, once I need this S cell to be 9 different from this adjacent cell, what is that going to do? It's going to require this to be 3, 6, and 0. Oh, no, it's not. Yeah, it is. Because 2, 6 is only 8. I can't get 9 different from 8. So yeah, this is going to be 3, 6, 0. That's the only option. And then this is a 2. So that did remarkably little. Let's see. Okay, with the 0, I have zeros looking at these cells at least. Okay, yes, now where does 0 go in column 13? Because column 13, reminder, actually does need a 0. I think column 13 might be the last place in this puzzle that we know needs a 0, but there really are 10 digits in column 13 if you count correctly. So because there are 10 digits in column 13, well, actually, you don't even need to do that. You can just look at this 5, 8, 9 triple and see that this can't be a this can't be 5, 8, or 9, so it's a 0. So just ignore the whole business. Okay, so this is now 2 or 4 or 8. Oh, it's not 2 because there's a 2 in the column already. So this is 4 or 8. Oh, but yellow needs a 4. So one of these two cells is definitely a 4. I don't know which one, which means this is not 4, it is 8. And yellow also needs a 7. And so this... So actually... oh yeah, this is not an 8, by the way. So this is not a 9. This is a 4 or a 7. Let me just get rid of these. This is a 4 or a 7. That's a 1, 4, or a 7. Somehow chat seems to not agree with me. Let me know if you think I did something wrong there. I felt good about that, but it's possible I did some shenaniganery there. I want to look at what this cell can be, because now this column is very filled in. It's not a 0 or a 1. It could be a 2. It's not a 3, a 4, a 5, or a 6. It could be a 7. It's not an 8, and it could be a 9, I guess. So that's very interesting, because I need to get to a difference of 9. So, in particular, there's definitely an S cell in one of these two cells now. And so I actually know where the S cells are, because this 2, 7, 9, there's no way to be 9 different. Actually, as soon as this was 0, that's true. Oh no, I don't quite know where the S cells are. Sorry, I was going to say something wrong. This is the point. This square here, they need to differ by an even number, which means these two are the same parity. That parity can't be even, so it's odd. So that's an 8. This is a 1, 7. That's a 4. No, I ruined it. I ruined it by going one too far. Okay. And now row 14, if I count 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't think so. Column 11 has 2 S cells. Column 11 has 2 S cells, right. So this is not an S cell. And so, so this is an S cell. Oops, sorry. This is an S. This is an S cell. So this is not an S cell either. So this is an S cell. Get rid of the X's there, I think. Okay, so we sort of have forced our S cell shenaniganery across there. So this is not an S cell. So if this is a 9, I would need this cell to sum to 18. That's not going to happen. If this was a 7, I would need this cell to sum to 16. All right, 7 plus 9 is 16. But then that I would need to use a 7 again, so that's not going to work. So this is a 2, and this cell sums to 11. Green can grow. I didn't use... I have been drawing borders when literally everything is resolved. Oh, except Yeah, S cells don't touch each other even diagonally. You're right, I prematurely bordered this one. Sorry, I was attempting to border them only when I knew where absolutely everything was, but I do not know where absolutely everything is in this region. So this needs to sum to 11. It's not 2, 9 or 3, 8. So it is 4, 7. Oh, also, this thing needs to sum to 11, and this is 2 different than it. It is not an S cell, so it's a 9 or a 13. Take your pick. Green, by the way, yeah, green can grow. I needed an S cell in one of these two. Yellow is not done because I don't know which of these is 5 and which of them is 9. Is the only reason why green is not done. So these, yeah, green does need to grow 1 cell. So what's the minimum sum for this? It's not 0 or 2, so the minimum sum is 1 plus 3 is 4. So this is at least 4. Be 4, 5, 6, 7, I guess, is the deal. This is, okay, so this is 4, 7, or 5, 6, we said. Not 5, because there's a 5 in the column already, because this is a 5, 9 S cell. Okay, so if this were a 6, it would be 1, 5, which would leave this being 4, 7. If this was a 7, I don't think this being a 7 works. If this is a 7, this can't be 0, 7. It can't be 1, 6, because it would break this cell. It can't be 2, 5. Oh, it could be 3, 4. No, it can't be. Oh, no, 7, 3, 4. This is 5, 6. Never mind, it works. Hey, Nordy, welcome. The 7 in column 15. This is not a 7. Thank you. So that's a 7. It's placed. Good night, Nicholas. Hope you sleep well. Where does row 8, column 13 and 15... Sorry, row 8, column 13 and 15. Where do they go in yellow? That's a good point. So this region has every digit involved in it. And so, because it has 8 cells. So these 2 digits, they have to go in here somewhere. And so the only place they can go is there and there. Now, I don't think that means they have a difference of 5, because one of these could be an S cell. And then who knows what happens. In fact, is it possible? Oh yeah, they could be 0 and 5 is one option. That 5, 9 is the only odd number allowed. Right, because this is definitely an even. So it would have to be these and another even if there's an S cell involved. Okay, 7 in green. So green definitely does need a 7. Green's 7 is in one of these 2 cells, which is very interesting. Because green has the potential to grow 1 more cell, but it has 7s looking at every other place. So one of these 2 is the green 7. I don't know that I have a great way to pencil mark that, but it tells me that blue's 7 is not in this column, for whatever it's worth. See, Garian says row 13, column 4. Row 13, column 4. Try again. Row 13, column 4, or row 13, column 5. Column 5 has to be a 0, otherwise you can't make a difference of 11. Okay, so yeah, so let's write in the candidates here. So these could be 0, they can't be 1, they could be 2, they can't be 3, Could be 4, 5. They can't be 6. Could be 7. Can't be 8 or 9. So we need to get to a difference of 11. The absolute maximum two of these can sum to is 12. And so Garian's point is, if I don't use a 0 here, that's never happening. And in fact, if I don't use a 7, it's never happening either. So 0 and 7 both appear here. And so, in fact, actually, once 0 and 7 appear, it's got to be 0, 4, 7, right? Because I need a difference of 11. The 0 needs to go by itself, and so then it needs to be 4 and 7. So these are not 2 or 5. They are a 0, 4, 7 triple. Okay, so this is either a 0, in which case this is odd, or yeah, never mind. This is I don't think I want to do this. Let's see. Kurban is asking about where orange is getting its S cell. Its second S cell. So orange could get much bigger. Let's see. Jaleb says this can only be 2 or 5. So if it's even, it's not 0, 4, 6, or 8, so it's a 2. And if it's odd, it's not 1 or 3. It could be 5, and it's not 7 or 9. Yep, so this is always a 2 or a 5. That's a very, very bright point. Okay, what about this cell? What can this be? Is this restricted? It's not 0, 1. Could be 2. It's not 3. It's not 4. It could be 5. It's not 6. It's not 7. And it could be 8 or 9. Now let's see. The claim is now this needs an S cell from J. Let's look at this. So it can't be 0, 4. It can't be 1, 5. Could it be 1, 5? No, it can't be 1, 5. There's a 5 in the row. 2, 6. No, there's a 2 in the row. 3, 7. No, there's a 7 in the box. And now all of the other ones involve an 8 or a 9, both of which are there. So yes, so there's an S cell here. Oh, sorry, wrong color. Ah! There's an S cell in one of these two cells. I agree. To make that 4 total work. It does make the 4 look like a 1. Also, 0s and 8s look identical. But we only have to work with the tools we have, so we have to just occasionally rely on the zeta to remove the lines so that we can look at them again and put them back. Like this one down here, I think looks like a 0, but it's an 8. Nope, it is a 0. I don't understand Kurban's argument about the orange S cell. The remaining red cell will be the other 2 or 5? I don't know. Row 8 is completed. 1, 2, 3, 4, 5, 6, 7, 8, 9. Row 8 only has 9 cells, if I'm counting correctly. Let's let's see. Okay, so I think people are telling me to pencil mark this. So there's no zeros involved. It could be 1, 2, 3, no 4s. Could be 5, or 6, no 7s, 8s, or 9s. So these are my options for this. Oh, no 2 or 5, actually, because there's a 2, 5 S cell in the row. So these are from 1, 3, 6. I need to make them work so that there's a difference of 4. Isn't that not possible? Yeah, I need to make these work so there's a difference of 4. Isn't the puzzle broken now? No, 1 and 6 is 4 different from 3. Okay, yes. So 1 and 6 versus 3 works. Okay. Good. Okay. You don't need 2 S cells in each row. There's at most 2 S cells in each row, is the rule, unfortunately, in this instance. Okay. Yeah, so the other 2, 5 is up here, is as was stated before, but I'm just going to restate it. The other 2, 5 is up here, in whichever of these cells connects. So let's see, if this was 4, this would be a 1, 3. If this were 6, this would be a 1, 5. But if this was 7, this cell would be a 3, 4. Sad, but true. So 0, which has a 1 on it. So what are the options here? So 1 plus 2 is 3 is gone. 1 plus 3 is 4 is gone. 1 plus 4 is 5, I think is an option. Oops. But 1 plus 5 is 6 is gone. Oh, no, sorry. 1, 4, 5 is not an option. 5 is already gone. There's a 5 in the row hiding over there. So 1 plus 5 is 6 is gone. 1 plus 6 is 7 is gone. 1 plus 7 is 8 is an option. And 1 plus 8 is 9 is an option. And I can't do 1 plus 9 is 10. So there's actually always an 8 in one of these two cells. For again, I feel like I'm sort of competing for the most useless possible deductions here. This cell actually is next to either... so the sum here is 8 or 9. And so this is next to an 8 or a 9. It's 1 away from an 8 or a 9. So this itself is a 7, 8, 9. Because the sum we just decided is 8 or 9. So both of these have a calculated value of 8 or 9. And so this itself needs to be a 7, 8, or a 9. And that gives us a 7, 8, 9 triple in the row. Right, the sum can't be 9 because it would force this to be an 8. So, if the sum was 9, then this would have to be an 8, but I've also used the 8 over there. So the sum is not 9, the sum is 8, and so this is 8, 1, 7, and this is a 9, is the point. And so now this digit is somewhat restricted. In particular, remember, green 7. Green 7 now can't be in any of these cells, so green 7 is here. This gets to be a green 7. And now green is done, so we can blacken in the rest of this. This row I need to now look at and say, okay, I've got 0, 1, 2, 3. I need a 4. Or no, I could have a 4. I've got a 5, a 6, a 7, an 8, and a 9. This is now just is a 4. Okay, so this is... Oh, this could be an S cell. Never mind. I don't know anything. But hey, we got the we got the green 7. We were on to the green 7 from the beginning, and we got it. Okay, let's remember what this is. This is a difference of 0 again. See, Gary's row 5, column 6 has to be an S cell. Yeah, so orange is big. One, 2, 3, 4, 5, 6, 7, 8. I don't see why. Oh, because if there's not, this has to be an 11 or a 7. Right. Oops. Yes, sorry. Very simple reason, not very complicated reason. If this is not an S cell, well, we know this cell needs to sum to 7 or 11, and it can do neither because there's a 7 in the row unless it's an S cell, so it is an S cell. Which means that these are both not S cells, which means... Oh no, I screwed up. I don't know that this isn't an S cell. All I know is that this cell contains a 7. So I'm going to get rid of the 3 in the corner. This cell contains a 7. It could be an S cell. Let's not screw this up. Okay. So that's the 2 for the row, though. So this is not an S cell. So this is an S cell. So now this isn't an S cell. And so the 7 is in an S cell. So my sudden panic was correct. The 7 up there is in an S cell. That means that this isn't an S cell, so this is an S cell. So this isn't an S cell, for the record. Okay. Also, row 8, column 12. Row 8, column 12. Row 8, column 12 is black. Oh, row 8, column 1, 2. Got it. Okay. So that looks like that. So that's not an S cell. Okay. Column 2's done on S cells now. So that's not an S cell. So that's an S cell. Which tells me now, because S cells can't touch diagonally, that that's not an S cell. So that is... because I needed an S cell here. And so now down here, this difference of 11 needed to be a 0 and a 4, 7. So this looks like this. 0 is the same parity as 2. So that is a 2. So this is not a 2. Could be anything else, though. Okay. Row 5, column 1 can only be 8. Why can't it be 9? Yeah, we've got all the S cells in red. 3 in the bottom of red is placed. Right. This S cell, right, remember, this is a difference of 4, so that's the 3, this is the 1, 6, sorry. I somehow got confused by this puzzle. One of these two is a 5. I just don't know which one yet. Row 5, column 1. So this cell needs to be even. And so it's not 4. Ah, right. Okay, this cell needs to be even, but it's also the sum of this cell. So it's not 0, it's not 2, it's not 4. So this is 6 or 8. Sorry, I misunderstood what chat said previously. I'm going to get rid of these x's, I think. If this was 6, I would need this cell to be 1, 5, and it can't be, because it can't be 2, 4, or 1, 5. There's a 1 in the row, so this is an 8, as claimed. Beautiful spot there. So now, what is this? It's not 1, 7, so this is either 2, 6, or 3, 5. I do not think I know which. This is horrible. There's definitely a 7 up here. But this 6 doesn't mean there's definitely a 6 here. 2, 6 uses all the evens. Okay, this is not 8 anymore. Let's do that. This is not 8 anymore, so this is odd. So this is 1, 3, 5, 7, 9. Who knows? The 8 looks down column 1. 7 is in green. Right, this isn't a 7 because the 7's up there. This is 1, 3, 5, or 9. Oh, there's 4 evens gone? Right, there needs to be an even in each of these. Right, these are single digits. They have x's implicitly, but they don't really. So there's an even and an odd in each of these, plus 2 more evens. So this cannot be 2, 6. If this was 2, 6, that would mean I had 6 evens, and I don't have that. So this is not 2, 6. It is 3, 5. Very good spot to... I had to add 11, got that. I had completely lost track of the fact that these weren't S cells already. So 3, 5. This 4, looking over here, makes this a 2, 3, and this a 1, 4, just for what it's worth. Just to keep up the things. Okay, what about this cell? Now that I know this is a 2, 3, I probably have a pretty restricted idea of what this cell is. Because this needs to sum to either 7... or not, or sorry, 7 or 11. If this summed to 7, it would have to be as 1, 6, because it can't be 2, 5, or 3, 4, but it can't be 1, 6 either, because there's a 1 in the row. So this is summing to 11. How are we summing to 11? We're not 2, 9. We're not 3, 8. We're not 4, 7. So we have to be 5, 6. 5, 6 is the only way to make this sum to 11. Which means we know what these digits are roughly, at least. Let's see, I still need a 0 and a 1. I've got a 2, 3, 4, 5, 6, 7, 8, and I need a 9. So there's definitely a 0 over here, is what we're saying. Because I need an even. Okay, but I don't think I really know anything else about the world. Oh, I think I've for a very, very long time... Oh no, sorry, I was about to say something wrong again. This could be 0, 7, 8. That's still possible. Let's see, what is it? What about this column? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Haha, we have all the digits in column 1. So That's black. And in particular, I need to put a 0 in column 1 somewhere. And I definitely can't put it here, because that would be saying the sum of this cell is 0. So, in fact, the 0 in column 1 is here. Because we just marked the 0 over here. It's over there. This 3, 5 makes this a 9. Makes that not a 9 anymore, or a 5 or a 3. Oh, it's a 1. So what are the digits that are left in this column? We've got 0, 1. We need a 2. We need a 3. We've got a 4 and a 5. No, we don't need a 3. Sorry, we have a 3. It's here. We've got a 4. We've got a 5. We need a 6 and a 7. And then we've got an 8 and a 9. So these are 2, 6, and 7. This cell definitely can't be 2. So therefore this cell is 2 and 7, right? Because this cell, remember, was definitely 7. It's also definitely 2. So it is 2, 7. So this is 6. And so now this cell has to be 2, 4 in order to add to 6 without repeating a 1. So this is 2, 4. If I look at what's left in green, I've got 0. I still need a 1. I've got a 2, a 3, a 4, a 5. I still need a 6. I've got a 7 and an 8 and I need a 9. So these are from 1, 6, 9 is the upshot of this. Oh, and these aren't 1, actually. Sorry. These can't be 1. So actually the 1 is forced over here because that 1, 7 looks over here. This 6, 9 now looks over and says that's not a 6. Okay, so I can get rid of that pencil marked 0. So now this is 7, 8, because I've got an X-wing on 9s. I mistyped row 5. Oh, oops, sorry. This is supposed to be 0, 1. Well, that's not good. Oh, no, it is good. It's fine. This is an X-wing on 9s. Right, the point was this 1 looked over and ruled 1 out of here. I just typed the wrong thing. But this is an X-wing on 9, so there can't be a 9 in this cell, or it would put a 9 in both of these cells. So this is a 7, 8. Which means this is an 8. The 0 in red looks up. Sure does. 1, 0. So does the 1 in red, for that matter, actually. This 7, 8 now looks down and makes that a 9 and an 8. The 9 looks up, makes that a 6 and a 9. I'll get rid of those X's. Okay. I'll get rid of these. Okay. I still need a 5 in one of these two cells. I still don't know which one to finish off red. That's amazing. I have to say. If this were not an S cell, it could not be 0, 6. It could be 1, 7. 7 there, 1 there, annoyingly. Yeah. Oh well, I thought this was going to be broken, but it's not. Yeah, bottom green needs a 1. I agree, and it's not getting it in any of those cells. It's not getting it there. So I at least know the last cell in green is a 1, so I can black out cells that can't be 1. So, like, there's a 1 in this column already, and green only gets one more cell that needs to be a 1 because of this 1. So this can't be a cell either because there's a 1 there. Let's see. There's a 1, 7 looking down here, so that's not green. There's a 1, 3 looking across this whole row, so these aren't green. So one of these two is the green 1. Did I really have a typo, or is the typo in the past? Oh, right. This can't be 1, 7. Okay, sorry. I was going through all the possibilities for this in the universe where this isn't an S cell. And I said 1, 7 was possible, but 1, 7 is actually not possible because there's a 1 in blue already. So it can't be 2, 6 and can't be 3, 9. So the point is this needs an S cell because we just went through all the possibilities. It can't be 0, 6, 1, 7, 2, 8, or 3, 9. So this is an S cell. That's the whole story. I don't know if it does anything, but it's true. That needs to be an S cell. 0 in row 8. That 0 looks over there, making that a 6. That not a 6. That 8 makes that a 0 and an 8. Let's see. Green needs a 3. And keep in mind the 1 in green can't be in an S cell. So the 3 in green needs to go here. Oh, and this can't possibly be a 4, and it can't be a 6 either. So this is a 3, 4, making 7. And so this is not a 4 or a 7. This is a 5, 6. So that finishes up that. Blue needs to get to at least 8 cells. Well, sorry, blue needs to get to exactly 8 cells. Even if it takes that one, it's only 7. So blue always takes this cell. And that cell is never an S cell. 1, 2, 3, 4, 5, 6, 7, 8. There's still plenty of room in that row. Okay, so I think I now understand a point I saw before. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's only one digit missing in this row, and we know what digit it is. Namely, it's a 9. Well, that digit certainly can't be a 9, and that digit can't be a 9 either, so those are black. I think that was Garian's point earlier that I didn't get a chance to look at, but I saw the gist of it. And so that was that. Okay, so therefore, blue needs to grow one more, so blue grows there, and now blue is done. You made the point in row 5. So let's look at row 5 and do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9 digits are there. So the only digit missing is a 9. So these two cannot be 9. And this one can't be 9 either because there's a 9 in the column. Well spotted. Okay. Row 7, column 4, 5. So I guess the question is, what is this? It's not 0, 5. I think it can be 1, 6, as long as it's in the right order. It can't be 2, 7 or 3, 8. Oh, no, it definitely involves a 6. Sorry, there's definitely a 6 on here is the point. So there's definitely a 6 here. For sure, just by sudoku. That 6 needs to get placed in this region somewhere. It goes on this dot. So this is either a 1 with a 6. And this 5 or 9 also goes up here. So there is a 5 or a 9 up here as well. And then we've got to think, if I've got a 6 and a 5, how am I making that work? So do something mod 5 or whatever. I don't think that this is that it's worth figuring this out quite yet, but there has to be an S cell up here for sure. Because there is a 6 and a 5 or a 9, and 6 is not 5 different from 5 or 9. So there's an S cell up here. There's no S cells in any of these places. 6, 4, 5 sounds good to me. As best I can tell, 6, 4, 5 sounds fine to me. Okay, what's going on in this row? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's 1 digit left in this row. Possibly. Or there's none. Just interesting. The S cell in row 2, column 7 cannot connect to orange, which already has 2 S cells. Yeah, okay, so yeah, this chunk can't be orange, because orange has 2 S cells. That's a good spot. Okay, so all of these are black. And no matter how this goes, it's going to have to get to at least here. So this is now part of a region that I can reward with a color. Let's make it another purple. Okay. Purple's always going to get to at least here. Because I need to get 2 S cells into it. It could be further, but it's got to get at least that far. Let's see, and these are different by 8. Oh, if these are different by 8... I'm not sure. Row 1 has all of its... row 1 has all of its S cells. And so because row 1 has all of its S cells, purple needs to go at least... Purple needs to go here and needs to grow. So purple can't possibly avoid taking these 2 is the point. Because this can't be an S cell either. And so I need to eventually take another cell in row 2 in purple. And no matter how I take that additional cell in row 2 in purple, this always becomes purple. That's cool. Okay. The S cell in blue should be 5, 8. Oh, this one down here. No, it's okay. I got it once I sat down and processed the message. So once purple is connected, it will be 8 cells. That's a good point from J. Dyer. So purple connects through one of these 2 cells. I don't know which, but that means every other place that purple could expand, it can't. And now that's going to put pressure on orange, because now orange needs to get to 8 cells. It could only get 1 there. And so even if orange takes that cell, it still needs 2 more. So these are always orange. And now this row looks sus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This row's now done. Orange could never take this cell, because now if orange took that cell, orange would be umpteen cells. So orange can't take that cell. But orange does need to get to 8 cells, so orange does take that cell, means it can't take that cell, means purple takes that cell. The second purple S cell is now on this 7. If I count row 1, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 digits in row 1, so this is black. So many things are happening. This cell cannot form a new region, as that region would need 2 S cells. And I can't put 2 S cells in a single cell because there's already an S cell in the column. Let's see. There's a 0 up here somewhere. 0 in orange. Where does it go? It goes exactly there. Because none of these things can be 0, and 0 is not odd. Oh wait, no, sorry, that's wrong. This could be an S cell. Never mind. I said something that was a lie. 2 in orange. Actually, let's just do, what are these digits? Let's do that. These digits are, let's see. We've got a 0, a 1. We need a 2. We've got a 3. We need a 4. We've got a 5, a 6, a 7, an 8, and a 9. So these are a 2-4 pair. It's the only thing they can be. Orange. Oh, no. Orange has all its S cells. You're right. This can't be an S cell. That was the whole way we got here. So my argument was actually good. That is a 0. And so now we ask where 3 goes in this mess. Wait, isn't orange broken? No. Orange is not broken. This is a 3. This can't be an S cell because S cells can't touch. So that's an S cell. Thank you to Jay for that reminder. So this is the 8. This is the 1, 7. Great. Okay, this row, 2, 3, 4, 5, 6, 7, 8, 9, 10. This row has every digit in it. I can't possibly have the 0 in either of these. So the 0 in row 2 has to go here now. Because if I had the 0 on one of these, I'd need to repeat a digit. So that's the 0, and that's the 8 going in over here. So now I need to put an 8 on one of these. Wouldn't it be 0, 7, 0? Oh! I can have a 0 on the 7 difference. Sorry. Apparently I can do this. 0, 2, 9. 0, 2, 9 would work. Okay, sorry, I was wrong. Right. I can't have a 0 on this different 0, but yeah, okay, you're right. Oh, neither of those can be a 0 anyway. Because of sudoku, because there's a 0 there and a 0 there. So neither of these is a 0. And I stand by my claim I can't put a 0 on a... Oh, this is not a sum to 0. This is a sum to 8. So I probably can put a 0 on a difference of 8. That's probably fine. Let's see. There were some other points about other things that I missed. I have 2 S cells in column 8 now. I do. So the point is, this isn't the S cell. This is the S cell in column 8. Well spotted by Kurban. So I need to get to a difference of 8. So I think the intended thing is for me to just write in all the digits that can go here and just force it. Let's do that. So 0, 1, 2, 3, 4, 5, 6, 7, 8. It's too many digits. It overflowed the thing. It deleted my 0 when I got there. Oh, no, I just typed 1 instead of 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. All of those could go there. Well, this doesn't look good. Let's see. We need a 0 in row 15. Okay, we're just going to pretend I didn't do that. That was a waste of time. 0 in row 15. 0 in row 15 goes here. Good spot to Thomas there. So now when I look at my 0 in purple, my 0 in purple is going over there somewhere. Okay, so I should not pencil mark both. I should only pencil mark this one, is what Kurban is suggesting. So, so this cell could be 0. Sorry, could be 0. It's not 1. It could be 2. It's not 3 or 4. It could be 5. It's not 6. It could be 7 or 8 or 9. Still horrible. Oh no, not 7 at least. I can rule out 7. So, oh yeah, good point. While we're at it, this 1 tells me where the 1 in green goes that we have been looking for. This is the 1 in green. Great spot to Isabella there. Okay, so can I rule any of these out? Is it worth it? If this is a 0, I would need to make 8 here, which I could not do. Because if this is a 0, I'd need this to add to 8, and it can't be 1, 7, 0, 8, 3, 5, or 2, 6, so this can't be a 0. Okay, if this is a 2, I need this to add to 10. And my ways of making 10, I can't use 0, 10. I can't use 1, 9. If this is a 2, I can't use 2, 8. And I can't use 3, 7, or 4, 6, so this can't be a 2. If this is a 5, I would need this to add to 13. That's seeming more likely. If this is a 9, I need this to add to 17, which I can't. Because if this is a 9... No, if this is a 9... No, it can't add to 1. Right. If this is a 9... this can't be, this doesn't work. Because if this is a 9, I need this to add to 1 or 17, neither of which is possible without a 9. So this is a 5 or 8 at the very least. Does column 3 need a 7? 1, 2, 3, 4, 5, 6, 7, 8, 9. Column 3 doesn't need a 7. 0 in purple and 0 in row 2 now. How did we get that this can't be 0? So I just have to, I really have to just keep doing cases. I've done so many cases to get here already. This feels, it feels very unlike the rest of the puzzle, because I feel like I haven't been doing a lot of cases, but we've already done 15 cases to get to this point. So, okay. So if this is a 5 and I put a 0 here, I would need to be 13, which I can't do with a 0. If this is an 8 and I put a 0 here, I would need this to be double 0, which I can't do. Okay, so this is all by way of saying my original point was actually correct, that this is 0 and 8. I mean, not that the point was correct, but that my wild speculation was correct, that the 0 has to go there, because the 0 can't go here by sudoku. Okay, and so now where do I put 0 in purple? Not there, there, or there. I put the 0 in purple there exactly. Let's see. Okay, do I want to look at 1s in purple now? 1 in purple can't go in any of these cells. It can't go there. It can't go... thought I saw somewhere else it couldn't go because there was an S cell with a 1 in it, but maybe I'm wrong. No, there was... 1 goes in one of these two places, but... yeah, somehow I thought I saw an S cell, but I did not. Let's see. Okay. This needs a 7 on it. I don't see why. Oh, no, I do see why, because there's a 7 there. Right. Just by Sudoku, there's a 7 on here. Okay. So 7 here with 5, 8 would work. Yeah, so one of these two is a 7, just by Sudoku, because I need to put a 7 in the region. 7 can't be on the S cell. If this was a 7, I'd have to be at least 7 plus 2 with a 3? Why can't I do 7 plus 2 with a 3? I think I can clear out these x's. 2 already in blue. Oh, there's already a 2 in blue. Got it. Okay. So I guess the point is just fill in all the digits. So 0, 1, 2, 3, 4, 5, 6, 7, 8 is the point. And then just grind from here. Okay, so this is not an 8. So one of these two needs a 7. And so if this was a 7, what would go with it? So it could be 7 plus 3, in which case this would need to be a 4. That doesn't work. It could be 7 plus 5. This would be 12. This would need to be a 6. That doesn't work. It could be 7 plus 8. This would be 15. This would need to be a 9. Doesn't work. So the 7 can't be here. So this is 7. I agree. And so now this needs to sum to 1, which it doesn't, or sum to 13, which it does, as 5 plus 8, making that a 3. Sadly, this 5 is placed in exactly the wrong place to resolve this thing. Let's see. 3 in this yellow is getting a little bit pinched. Let's see. Okay, so 3s. Okay, can we now do 3s in purple? 3 not there and not there. Yep, we can do 3 in purple. 3 in purple now goes here. Good spot to Dale Mox there. What do these digits have the option of being? Not 0, could be 1. Not 2, not 3, not 4, 5, 6, not 7, not 8. Could be... No, they can't be 9, because this region... No, they could be 9. This region does need a 9. So this one's certainly not 9 or 6. So this one is 1, just by the column. So this one's not 1. Oh, there is a 9 in the row. I just completely missed the 9 in the row. So actually, together with that cell, that actually just disambiguated everything. So now, you'd think that would place a 6, but it doesn't. We know there's a 6 in this cell, but we don't know if this cell is an S cell or not. Let's see. 3, 4. 6 in the S cell in column 6. 4, 5, 6. Yeah, we said that. We got that one. Row 2, column 7's S cell must sum to 13 or 16. And either way, it involves a 9. let's see. Okay, so and then also I'm being told that 8 is placed in purple, which I don't see. Okay. It's in one of these two cells, right, for 8. S cell 8's look up. Ah, there's one way at the bottom. You can't expect me to see something 14 cells away. That is too far. So 8 is actually placed here, from that little itty bitty S cell all the way over there. So that's an 8. And so now this needs to sum to 0, or 16. And so the only way to do 16 is 7, 9. And the only way to do 0 is you can't. So this is 7, 9. And so these digits are 2, 3, 4, 5, 6, 7, 8, 9. This is not a 2. So the only way I'm making these numbers work is to be a 2 here with a 4, 5 S cell here. So that resolves this S cell and this non S cell. And I believe that lets me, by the zeta rules, box this in, because I think we actually have this region done now. And now, finally, this 4, 5 resolves what's going on with red. So now red goes here, gets its 5 that it has been wanting, and now red gets to be blackened in. So now we come here, we blacken that cell. Sorry to all of the Wordle fans, by the way, although I suppose you deal with this a lot, but my word. Let's see. Blue's allowed to have a border. Blue just doesn't look done because it's got row and column markers in it. But blue is allowed its border. Green is also allowed its border. The ones that have row and column markers in them look like they're not done, even though they are. Other red. And other red as well has now gotten sorted out. Yeah, this blue and this green. Yeah, the blue and the green at the bottom are also done. Lots of stuff got done. Okay. It's regrettably come time to force this, hasn't it? Okay, what is this digit? I'm going to get rid of the X's here. Okay, this digit... this digit, it doesn't have many options. It's not 0, 1, 2, it could be 3. It's not 4, 5, 6, 7, 8, or 9. So this is a 3. What about this digit? It's not 0, 1, 2, 3. It could be 4. It could be 5. It's not 6. It's not 7 or 8. And it could be 9, I think. Okay. Can't be 5. Oh, there's a 5 down there. Yep. Sorry. The one of those little itty bitty ones. Yep. The itty bitty 5 still looks all the way up. Okay. What about this one? Not 0. Could be 1. Could be 2. Not 3. Could be 4, I think. Could be... no, can't be 4, because of that one. Could be 5, I think. Can't be 6, 7, 8. Could be 9. Okay, and then this one I think is going to be the most ugly. Let's see. So this could be, it's not 0, it's not 1. I think this one can be 2, not 3. I think it could be 4. Could be 5. Can't be 6. Can't be 7 or 8, and could be 9. No, it can't be 9. There's a 9 in the column. Okay. Can't be 5. Ah, there's a 5, 6 looking up there. There we go. Not 5. Okay. So, well, I was hoping that would do more than it did, I'm going to be honest. Because I really don't want to think about all the options of this. Ah, that makes this even. So that makes this not even. So it's not a 2 at the very least. So this is 1, 5, or 9. Let's see. This is not a consecutive dot. This is a different parity dot. Yeah, I think we should be connecting the missing region or something. So I guess here's the point. This has to connect to row this one. This has no option. It needs to pass through this row. So, because I can't put 2 S cells up here. There's already an S cell in the row. So this needs to pass through this row. Could maybe do that. No. Yeah, this can't take its S cell in this row, because this row already has 1, 2, 3, 4, 5, 6, 7, 8, 9 digits. So this needs to take an S cell in at least this row, and there's no way that it gets to this row without merging with this region. So these are the same. They are going to be purple region number 3. So what about this? So remember, it doesn't have a 6 on it. So it doesn't have an 8 or a 9. So, and it can't be 7, 6, can't be 6, 5. Can't be 5, 4, because there's a 5 already. Could be 4, 3, I think. Could be 4, 3, or 3, 2. Or 2, 1. But can't be 1, 0. So I think these are all from 1, 2, 3, 4. That one can't be... Oh, actually, neither of them can be 1, because that one looks down, that one looks up. Ah! This 3, 4! That does it. This is a 2. And so, therefore, this is a 3. Okay, so that 2 now finishes up a little bit of this mess in yellow. This is now a 4. Oh no, couldn't it have an S cell? Oh no, oh no. You're right. Ugh. This puzzle started out so nicely, and it got so grindy at the end. Let's see. This is, how many cells do I need here? Let's see. I need at least 1 to connect. 3, 4, 5, 6, 7. Okay, so I don't get many more cells. Yeah, I guess we just got to keep pencil marking yellow. Okay, so this cell definitely has a 6. Okay. 0, 1, 2, 3, 4, 5, 6, 7. No, not 7, 8, and 9. Okay, so this is only from 4, 6, 9, and definitely contains a 6. Okay. This one is the messy one. So can't be 0. Could be 1. Can't be sorry, could be 2, I think. Can't be 3. Looks like it could be, no, it can't be 4. There's a 4 below it. 5? I think it could be 5. Can't be 6, 7, or 8. And could be 9. Okay. So now we have to figure out what ways we're actually making a difference of 5, given that this cell has a 6 in it. So if this is a lone 6, then this needs to be a 2, 9 S cell. Otherwise, this could be a 6 with a 4 going with a 5, or a 6 with a 9. It can't be a 6 with a 9, actually. So there's never a 9 here, because 6 with 9 would mean this would need to be at least 10. So this is not a 9. So this is a 4. It's either a 6 by itself, or it's a 4, 6. So we just have to write down all the possibilities. So 6 by itself would go with 2, 9. And 4, 6 would go with 5. So this cell is never a 1, or never contains a 1. If this is a 1 by itself, then this becomes an S cell, which is 10, which doesn't work. If this is a 1 with something else, it would need to sum to 11, and I'd need a 10. So this never concludes a 1, which now means this is a 1 over here. So we have that. 2, 9 breaks the region. Okay, let's just do Ransk's point, because I understand Ransk's point, which is now look at where 5 goes in this region. So now 5 goes here. Sorry, I should say this way. 5 is included in this cell. So that's a 9 and a 5. Now 9 is not included in this cell. If I made this an S cell, its sum would be 7, which does not work with 4 or 6. So this is not an S cell. It's just an ordinary 5 with an S cell 6. Or sorry, an S cell 4, 6. Oops, sorry, wrong color. And so this cell now is the 9. That's the 2. It's a 4 and a 2. I can get rid of that X. This now earns a border. Orange now earns a border. Okay. So, other yellow gets a border. Puzzle's super awesome. But I have this problem with, I think, most of this kind of deconstruction. It's the same problem that chaos construction puzzles have, which is that the last third of any one of these puzzles is kind of agony. Let's see. Okay, so I can also remove the line. Yes, I can remove this line. So in the sense that I really look at variations of this to solve the chaos construction problem, where chaos construction has like all of these cool things, but then the end of it is a little ugly, it doesn't quite get around that. Okay, so 1 and 7 in purple is quite interesting, because none of these cells can be 1 or 7. As being pointed out by Z Hunter. By the way, welcome, Z Hunter. So it's very interesting because purple is already at 6 cells. And so the other 2 cells that purple takes doesn't... Oh, no. Purple gets to take... Okay, so what has to happen then is that purple has to connect here and then take a 1,7 S cell over here. Because if purple does not take this cell, I can't put 1 and 7 in here. Well, good news, Crankoon, it's almost done. So yeah, so purple needs a 1,7s cell because purple needs to connect. Yeah, so that's insane. So the question is, which of these cells can be a 1,7s cell? Not that one for sure, so that's gone. Purple needs, again, a 1,7s cell, so these cells aren't purple, those cells aren't purple, that's not purple. That now has become isolated. Let's see, could this be a 1,7? Okay, well, could this be a 1,7? Yeah, S cells can't touch. S cells can't touch. Ah, right. This can't be a 1,7s cell, right? I was missing that S cell. So this is the 1,7s cell. Very well spotted to Z Hunter there. Welcome to the stream, by the way, Z Hunter. So now that is black and that is black. Okay. And so Ranks points out that if I look at this, these cells can't be 0, that cell can't be 0, this can't be 0 from above, this can't be 0 from below, so there's no place for a 0, so there cannot possibly be another region. Okay, so we now just have to finish up this, this thing. So this digit is a naked single, it's a 4. These now have to be 2, 3, I believe. It doesn't get a border until it's done. So if I just look at this again, this now... So I did this before. This row has has 4, 5, 6, 7, 8, 9. So these are from 1, 2, 3 only. Oops, sorry. This one is not 1. Somehow before it turned out... this one's not 1 either because of the secret 1. So these are a 2, 3 pair. That 3, the secret 3 looks up and makes this a 2 and a 3. And so these are 0, 1, 2, 3, 4, 5. These are 6 and 8, I believe, if I counted correctly. And we know the order is that one's 6 and that one's 8. And now it has earned its border. Awesome puzzle. I really enjoyed that. Very cool. One of the coolest uses of S cells that I've actually seen. Let's see. So let's see. I started at like 410, something like that. The solution is correct. Woohoo! So I started at like 4:10, something like that. I don't know the exact time I started. So about 3 hours. But what a cool puzzle. That was very neat. Yeah, I really like this kind of deconstruction. My only... the 197 minutes is wrong because I had this open before I started streaming. And I did not restart it when I was doing it. So the 197 minutes is a bit over. I'm sure this is short of Niplu Ultra. So I think Niplu Ultra was 3.5 hours, and this was well short of... This is at most 3 hours. Yeah, so... But awesome puzzle. I really like that. I really like these sort of Suguru deconstructions as well. Aside from the, as I said, sort of the end part. But I mean, it's the same exact problem that chaos constructions have, where you just sort of have to suck it up and deal with it because the puzzles are so cool, and you get a really cool, like, first 2/3 to 3/4 of the puzzle, and then there's just nothing the setter can really do, I don't think, to make the end nicer, because I think anything you did to sort of smooth out the ending would break all of the earlier stuff. Which one did Meme Rister solve that took 3.5 hours? I know Meme Rister is planning to solve vignettes, which is one of mine later next week. And vignettes actually is fascinating because the times that people who have solved vignettes have spent on it have ranged from 58 minutes to over 3 hours. So depending on how it goes, vignettes may take Meme Rister another 3 hours, or may take Meme Rister an hour, depending. It's very interesting. I don't think I've ever had a puzzle where the solve times on really skilled solvers varied so widely. This is a very awesome monstrosity. I'm very happy that that my supporters voted for me to do this. So anyway, speaking of support, I feel like if ever I have earned your support, it is by doing this. The support for the channel comes from a few places. But basically it comes from all of you who are watching. So if you like the chat or if you like the video, that's great. If you subscribe to the channel, that's even better. And if you want to give back to the channel in some way, there are 2 ways to do that. Actually, 3 technically. You can always do super chats, like David Ratner did a super chat earlier. Thank you very much, David. Much appreciated. But if you want to sort of become a fancy supporter and get that green name next to your chat, like Naverio and Kurabon are showing off there, and Jay, all of them in chat showing off their Math Pesto too, all of them showing off their fancy green badges. Then you can do that by hitting the join button down below. Again, people who support on YouTube can vote on the puzzle. So this was voted on. So this puzzle, by the way, if you're curious, the supporters who voted for this puzzle are Woofer, Doomdiat, Crispy, Russ, and David Ratner. So this solve I dedicate to all of you who voted for this. You also get emotes like the lovely Zach emote that is in there if you want to do that. If you prefer Patreon, you can support on Patreon. You can't get the emotes or the green name on Patreon, unfortunately, but you can get access to the bucket. You can see all the upcoming puzzles. You can vote on the puzzles. If you support at the highest levels, then you can actually suggest puzzles and they can get added to the bucket. So we have that. All of those are options. And so, and actually we had a bit there where we were getting, like 10 votes for the puzzle that was most voted on, so it was becoming a little difficult. But now people are voting a little bit more spread out, maybe because the bucket's so big. So now actually this got voted on as the most voted on puzzle with only 5 votes. So your voice can have the power to shape the future if you do that. Alrighty, I'm going to take a real quick break. Jay Dyer's going to go to bed. Good night. Hope you sleep well. We're going to come back and we're going to do another puzzle. Another puzzle that is not going to take 3 hours. I'm going to take up something short to finish up the stream, but I'm going to take a short break, stretch my legs, and I will be right back. See you all shortly. Night Math Pesto, thanks very much for the puzzle. I really enjoyed that. Do not interpret my design griping at the end about how these puzzles always have a slightly grindy end as me saying I did not like the puzzle, because I very much enjoyed the monstrosity that you have created here. The enjoyment was just concentrated in the first 2 hours of the 3 hours. But there is still much enjoyment to be had, so don't, again, interpret the general design philosophy as saying I did not like the puzzle, because this was awesome and great fun. Anyway, short break, and then I'll be right back with another puzzle, which will be more accessible than this puzzle, a bar that I think will not be difficult to clear. Alrighty, welcome back. We are back with this more innocent-looking puzzle by Derektionary. So this is called Congregate. And so, as I mentioned at the beginning of the stream today, I've been doing these Sudoku tutorials where I go over common Sudoku variants and talk about techniques for them. And so far I've done 3 of those. One was on how to write stuff in Sudoku that you're solving. One was on white dots and black dots. And one was on arrows. So this puzzle happens to beautifully combine everything that I've done a tutorial on. Again, if you look at the channel and you just click, all the tutorial videos are already there, uploaded separately. So if you want to go back and look at the tutorial videos on any of these things, that is an option. Alrighty. The funny thing is the video that it already is the digit that it's going to be is the same digit it was last time. Okay, we'll not make this the bet cell. Do you have a suggested bet cell, Derektionary? Just to explain the rules, the way that arrows work is that the digit in the circle always gives you the sum of the digits along the arrow, so it could be something like that. Digits on white dots have to be consecutive, so I could do something like that. And digits on black dots have to have a ratio of 2 to 1, so one is double the other, so it has to be something like that. There's no negative constraint, so I don't know anything about, like, if there's other digits, like, it's fine if this is a 4 and this is an 8, for example. Alrighty. So the fancy fact about arrows, or one of the fancy facts about arrows, is that you can't put a 9 on an arrow. And so let me just elaborate on that slightly. If I put a 9 here, whatever digit I put here, let's say I put a 2, I now have to put an 11 in this cell, and that's not going to work. We have officially the bet cell is row 9, column 1. I like the black bet cell, actually. That looks pretty cool with this black dot, white dot thing. And so what that means is I have to put a 9 in box 5 somewhere, and I can't put it in any of these cells, so therefore I have to put it here. And so we can bring in our professional digit dancing penguin to do the 9 dance. Whoop-a-doop, whoop, doop-boop-doop, boop-a-doop-doop, whoop-a-doop-doop, doop-boop-doop, whoop, doop-boop-doop, doop-boop-doop, whoop-a-doop, woo, doop-doop-doop, doop-a-doop. Ah! Wah! Ba-da-ba-da-ba-ba! There we go. Thank you, Zach, for that lovely 9 dance. You've got to do 2 9 dances in one day. Very exciting. So these 2 cells each have to be at least 6, because the minimum I could make these arrows sum to is 1, 2, 3. So these each have to be at least 6, and I might be able to do better than that if I try and slice it differently. Maybe not immediately. No, the minimum these if I try and do this differently and say, okay, the minimum these 4 digits sum to is 10, plus the minimum those 2 sum to is 13, then I'm saying these sum to at least 13, which of course they sum to at least 13. So that is not super exciting. So let's see. Yes, that's a good point. Where does 9 go in box 6? That is an excellent question from SPQ. And the answer is not on a black dot, because if I put a 9 here, I have to choose to put either a 4.5 or an 18 here, neither of which will work. So that's the 9. So one of these 2 is a 9. Now, where is 8 in box 5 is a good question. 8 has to be one of these 2, because if I put an 8 here, again, I need to add 2 numbers to it. I can only add 1 number to it. So 8 needs to go in one of these 2, and it can't be that one. Because if that was an 8, then this would need to be a 1 and a 9, and I already have a 9 in this column. So actually, this is an 8 and a 1 and a 9 going like that. So there's a 9 up here somewhere while we are marking places that 9s can live. What about in this box? I I guess we have a little more gamut. Okay, so what about 7? Where does 7 go in this box? So 7 can't go here, because again, I would need to add... actually, no, maybe 7 could go there. Never mind. So, no, 7 can't go here, because this would sum to at least 9 already. So 7 doesn't go on this arrow. 7 can't go here, because this would sum to at least too many. 7 can't go in either of these cells. 7 is not 8 or 9. So the 7 actually goes in one of these two cells, which is interesting. So if the 7 goes here, then this is a 1 and a 1 and a 9. If the 7 goes here, then this is a 7 and a 1 and a 9. That's an excellent question, or an excellent point from Corporate Commander. Look at row 6 and ask where the 7 goes. So I can't put a 7 on a black dot. I can't put a 7 on a length 3 arrow. I can't put a 7 on an 8. We already argued I can't put a 7 here. I can't put a 7 there either for sure. And so the only places I can put the 7 are exactly the same places I put the 9. So we have a 7-9 pair here. Which is cool. Let's see. People want me to do min and maxing sums. I was hoping to avoid that in a 2-star puzzle. Let's see. Well, let's see. I guess we can if we absolutely have to. So what is the sum of all of the arrow cells in this box? So the sum of all of the arrow cells in this box is 45 minus 17, which I think is 28. And so if I now throw in these, I'm now at a minimum of 38. And so if I now throw in these, I'm now at a minimum of 41. And so if I throw in that one, I'm now at least 42. So the sum of these circles has to be at least 42, if I did that correctly. So what is the maximum it could be? 9 and 8 and 9 and 8 would be 34. And so this would still have to be at least 6, even if that is 9 and 8 and 9 and 8. But that doesn't actually seem useful. I mean, I can say that this is from 6, 7, 8. Oh, at least 8. Okay, let's do the math again. So if this is 8 and 9, and this is 8 and 9, that's 34. And I need to get it to at least 42. Right. So right. I just did my math wrong. So then the arithmetic immediately gives us this digit is an 8. Okay. So free digit, or arithmetic-y digit. So that places an 8 down here. Oops. Sorry, it places an 8 down there. And these have to be 8-9 pairs, because we only got to our minimum if we did them as 8-9 pairs. We did make green a 1 in that version. These have to be 1, 2, 3, 4. These have to be 1, 2. And so we get all of that. Okay, so this isn't the 9 anymore, because there's an 8-9 pair in the row. So yeah, there's only 1, 1 on these two arrows collectively, so that arrow has to be a 2, 3, 4, as Corporate Commander is pointing out. Ah, yes, where does the 1 go? So there's a 1 in one of these cells, there's a 1 in one of these cells, so where does the 1 in box 5 go? It has to go in this row, but there's a 1 there, so the 1 in this box goes here. Very smart point. Let's see. So it's funny, the other day, I think it was in VC1, we were talking about how no one actually likes min-maxing in puzzles, but apparently Derektionary likes min-maxing in puzzles. Okay, so yeah, the 2 also, the 2 in this box is in one of these cells, the 2 in this box is in one of these cells. So this is a 2. And so now these are a quad, 3, 4, 5, 6. Okay, so now I can ask about the 8 in this row, right? So I've got 5 cells there, I guess, but I know one of these 2 is an 8. This digit has to be now a black dot digit that's not a 1, 2, 3, 4, or an 8. So it can only be a 6 with a 3. So these aren't 6. Now this only... Oh, no, not quite. This can't be a 3, though. If this were a 3, this arrow can't get big enough. So this is not a 3. So there is a 3 on this arrow, for whatever that's worth. Okay, these digits are a tuple, so let's just fill them in. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 5, 7, 8. So these digits over here are a 3, 4, 6. Yeah, these are a 3, 4, 6. Okay, so what is this digit? It's a black dot digit that's not a 3, 4, or 6. So this can only be a 1 or a 2. Sorry, it's not a 3, 4, 6, 1, or 2. So what digit is it? It can only be an 8. So that's an 8 and a 4. I love that. That was very slick setting. So this is a naked single, right? This is not 1, 2, 3, 4, 6, 7, or 8, or 9, so it's a 5. So this isn't a 5. That's not a 5. Right. We know the one of these that sums to 9 is a 2, 3, 4. Because one of these has to be a 2, 3, 4, because between all of these cells, I only get 1, 1. And so the 9 arrow is a 2, 3, 4. So that arrow can't have a 6 on it. That's the point. So that gives us a 1, 2, 3, 4 quad here. So this is a 6. So we've got that all worked out now. So yeah, if we've got a 2, 3, 4 arrow, I was trying to unhighlight that, not highlight it. Let's see. Okay, so do I want to think about 9 in this box? No. Do I want to think about 8 in this box? No. Okay, so 8 in this box now can't go here or there. Got it. Okay. Where does 8 go in box 1 is the question. So 8 in box 1, just by sudoku, goes in these places. It can't go here because it would require another 4. It can't go here because there's an 8, 9 pair in the column. So 8 in this box is always in one of these two cells, which means this is never an 8. It's a 9 and an 8, and an 8 and a 9. That is the zeta kind of deduction that I like that. Okay, so the 9 we said was a 2, 3, 4. So one of these is a 2, so none of these are 2. And so if this is going to sum to 8, with a 1, 3, 4, a 1, 3, 4, and something, the other thing has to be the 3, 4, making this a 5. So now I do maths. 2 plus 5, I need a 2. Hopefully there I need a 1 in order to make that work. Okay, so this is a black digit that is not... Oh, sorry, let's just fill in this column. 1, 2, 3, 4, 5, 6, 7. Okay, well, this is not a 7. So this is a 3 or a 4. And it can't be a 4, because if this was a 4, this would need to be a 2 or an 8. It can be neither. So this is a 3 and a 6. I love black dots. Black Kropke are like the coolest mechanic. We won't talk about what just happened. If you missed it, it just didn't happen. So this 4 looks over and says this is a 7 and a 4. Okay, this dot now has to be a 1, 2, because it can't involve a 6 or a 4. So this is a 1, 2. Let's see. This can't involve a 3 or an 8. So it's from 1 to 4 at the very least. There's always a 2 on it. Let's see. There's a 7 down here somewhere. It's not there. Yes, I should probably look at column 3 and pencil mark it. So column 3, we've got a 1 and a 2. We need a 3, 4, 5. We've got a 6. We need a 7. We've got an 8 and a 9. But this dot, as Ranks points out, needs an even number on it. So that even number must be a 4. So this is from 3, 4, 5 only. And the 4 is here. So actually, this is a 3. These aren't 3. And that's a 7. Sorry, that's a 7. Yes, you definitely have to find the places to put zeros in every Sudoku puzzle you do, or you're just not really thinking about the puzzle. 3 in this box needs to go here. So this is not a 3. That's not a 3 either, actually. If you look very closely, you might have discovered that this wasn't a 3, because I put a 3 there. These two digits are a 5 and a something. 3, 4, 5, 6, 7, 8, and a 9. Placing a 9 there. These digits are a 2, 3, 4, 5, 6, 7, 8, 9. That one's not a 6. That one's not a 2. Let's see. This row, we've got 1, 2. We need a 3. We've got a 4. We need a 5, 6. We've got a 7. We need an 8. Okay, so that one's not an 8. This one's not a 3 or a 6. So this one's a 5 or an 8. Let's see. What can this not be? Maybe this can be anything. I think this can actually be anything. Oh well. That 4 looks down here and makes that a 6 and a 4. 9 gives me a 7 and a 9. Let's see. This can't be a 1, but that can be. Let's just write these in. These are a 1, 2, not a 3. Oh, sorry. There's a much easier point. That 5 looks at this. This is a 2. That's going to make this much easier. So these digits are 1. We've got 2, 3, 4, 5, 6, 7, 8, 9. These are from 1, 4, 7. 1's not adjacent to any of those things. Unfortunately, 4 and 7 both are adjacent to some of those things. We've got some amount of leeway there. So these digits, let's fill in. We need a 2. Got a 3, 4. We need a 5 and a 6, and then we've got 7, 8, 9. That one's not a 6, at least. Could be anything, I believe. Okay, so let's look at 8s, because we've got lots of 8s. So, in particular, there's an 8 here. Just by sudokulology. This is not an 8. Let's see, what about 7s? 6s? I don't have all that many 6s, actually. 5s. 4s. 3s. Oh, this column. Let's fill in this column. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are from 3, 4, 5, 6. So that one's not a 3. It's from 4, 5, 6. I have 8 9s in the grid. How did I click every digit but 9? That's a 9 is the point of chat. Thank you, chat. I was going to try and look at this. So could be 3, 6 in this direction. Sorry. Could be 3, 6 in this direction. Could be 1, 2 in this direction. Or it could be 2, 4 in either direction, I believe. If this is a 2 or a 4, that gets us a triple in this box. That seems fine. Oh, look at this column. Where is the 3 in this column? The 3 in this column is down here. So by locked candidate logic, this can't be a 3. That's very nice setting. So this is a 2. And so this is a 1 or a 4. That makes us a 1, 2, 4 triple, as promised. And so these remaining 3 digits are not 1, 2, 3, 4. They are 5, 6, 7. Not 8 or 9 either. Let's see. This one's not a 6. It is a 5 or a 7. Yeah, so I've got a 5, 7, 8 triple in this column. The 5, 7, 8 triple gives me a 2 here. Means that this is the 2 that goes on this white dot. That's not a 2 either. This is now a 2. It's the 2 that goes on this. Do I have all my 2s now? Nearly. But I don't know what order the 2 goes in that order, or in that row, I suppose. Let's see. What about 3s? Yeah, the 3 I know goes in one of these 2 places. Let's see. Okay, this column has a 3, 4 pair in it. So what's left? I need a... No, I've got a 1, 2, 3, 4 already. So I need a 5, 6, 7. I've got an 8 and a 9. So these are from 5, 6, 7. Okay, so... oh, that almost, but not quite, got me a 5, 6, 7 triple kind of thing. Sad. Okay. Boy, there was some discussion the other day about difficulty inflation. I feel this being a 2-star, this being a 2-star puzzle is quite a statement about where we've come in Sudoku. 1, 2, 3, 4, 5, 6, 7, 8. This is not 1 or 8. Oh, this is not 8 either, because there's an 8 in the box. Or 2. This is 1 or 6. It's also possible that my brain was just destroyed by the previous puzzle. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is not 1 or 3. It is 2 or 7. This is not a 2. This is not a 2. I mean, it's not like it's unpleasantly difficult. I'm just surprised that it was marked as such. One of these is a 1, I know. Let's see. Yes. Where does 4 go in row 7 is a good question. 4 in row 7 only goes here. So that removes 4 from these 2 places. Someone else saw that as this sort of like weird shaped 4 X-wing. Row 2, column 7. Let's see if this is a 7. Right. Okay, so we already have 3 5, 6, 7, 8s. If this is a 7, we now have 5 5, 6, 7, 8s. And 5 is too many 5, 6, 7, 8s, because if you count carefully, 5, 6, 7, 8, that's only 4. So this is a 4. So this is not a 6 or an 8. That was a really good spot, Tegarian. These are not 4. This is a 1 and a 4, and a 5 and a 4. The 1 looks over here, says that's not a 1. This 1 looks up, says that's not a 1, so that is a 1. So that's a 7 and a 1. So that's a 5. That 5 looks up and says that's not a 5. This 3, 5, 6 triple says that's an 8. So that's a 7 and an 8. That 7 says that's a 5. So these aren't 5. That 7 says that this is a 6 and a 7. That is not a 7. That 5 and 6 say that this is a 3 and a 7 and a 2 and a 6 and a 5 and a 6 and a 3 and a 5 and a 6 and a 5. 2 says that's a 1 and a 2. 6 says that's a 1. Let's see. Where did my 3, 4 get sorted out? Let's see. This is not a... Oh, this should just be a write-in. I should just write it down. 1, 2, 3, 4, 5. This is a 6. This had better be a 7. How is this getting sorted out? I must be missing... this 4. That 4... Made that a 3 and a 4 and a 3 and a 4. And then that is a 3. There we go. Very nice puzzle. All very cool stuff. Yeah, I liked that one a lot. This combination of arrows and Kropke is always going to get me. As something I'll be like, that could be cool. Kropke just makes such a cool include in just about any imaginable constraint. Oh, congratulations, Isabella. Yeah, very nice. I really liked the setup of, we've got all of these arrows poking into box 5. So that you can figure that out. Very sweet. Alrighty, well that's gonna about wrap it up today. Thanks to everyone for hanging out today. It's been a fun day. I really enjoyed the puzzles today. There were only 2 of them, but hey, if you missed the first puzzle, if you missed the Math Pesto puzzle, I think it was well worth going back and watching some of the really cool stuff that happened in there. It was quite a puzzle. You can watch it at 2 times speed if you want. I won't tell anyone. But I will be back on Wednesday with more Sudoku. There will at some point, I appreciate people asking, there will at some point be more Outer Wilds. I don't know when yet, but we will find a time to do more of that. Welcome, Tom C, by the way. I'm not sure if I've seen you chatting before, but welcome. Glad to have you. Ranks is going to be streaming later, so in about an hour, if you want to go watch some more board games, sorry, not board games, more word games, Ranks will be streaming, so you can go check that out. Again, thanks everyone. And I hope to see you all back. Especially, I saw a bunch of new folks today, so I hope to see you all back soon. But that's all for me for now. Thanks to the super supporters, David Ratner, Michael O'Connor, Nordy, Franco, and Woofer. Thank you very much. And I will see everyone next time.